Andate a casa, non c'è nulla da fare. 25 anni fa, una diagnosi di distrofia muscolare di Duchenne.
È vero che i miei muscoli diventano sempre più deboli.
Una patologia degenerativa rara che colpisce i muscoli. Ma c'è chi non si arrende e fonda Parent Project. Intanto il mondo cambia e anche Parent Project cambia un po' il mondo.
Ringrazio Parent Project e l'opportunità.
L'ultimo anno finanziato da Parent Project.
È un project che ha circa 8 anni nella prima volta in maniera.
I pazienti oggi hanno un futuro da immaginare, degli obiettivi da raggiungere e dei traguardi da conquistare. Oggi, anche con la Duchenne puoi diventare ciò che vuoi. Come Luca
Buzzella, che ringrazio per essere qui.
Morire insieme, in fin dei conti, è una sfida già vinta.
I'm here to tell. The future is there.
Jacopo,
Alla Duchenne.
Matteo, Lorenzo, Luca, Samuele, Francesco e come tanti altri ragazzi che vivono una vita piena. Ma questo non basta, non c'è ancora una cura e tanti sono gli ostacoli da superare e le strade da aprire.
Tutti insieme abbiamo formato una grande famiglia.
Scrivi i prossimi 25 anni di storia insieme a noi.
Buonasera, vi ringraziamo per essere qui con noi anche quest'anno.
Good evening, thank you for being here with us this year. Of course, we would have been delighted to see you in person rather than on this spaceship. And we hope this spaceship will take us to our final goal, a therapy for this disease. And we hope that the journey to get to the cure, well, will be as light as possible. We are speaking today about gene therapy. It is an extremely difficult subject for all the families, especially for the families who are at their first conferences. So I ask the researchers who are here with us to remember that this conference, this meeting, is a meeting that has been essentially imagined for families, families who have done something completely different in their lives, and now they are in front of a video to hear about these difficult topics, but topics that can help them live as well as possible this difficult situation they have suddenly found themselves in. So please be clear, be educational, and these are essential subjects for us. I mean, you cannot learn everything in one day, but that is something that will go on in the next years. To better understand these topics, we have here with us very expert people, such as my co-pilot, Commander Fernanda De Angelis, and I give her now the floor, and she'll be the pilot of our spaceship. From now onwards, Fernanda will give you the basis of our trip, and then Professor Mercury, who will again give you some small indications concerning our journey. I'm very glad to start this very adventurous journey with all the updates coming from scientific research in this first session of Saturday afternoon. And as my co-pilot said, we start with a presentation, with my presentation. It is an introduction of such as a sort of ABC of gene therapy. DMD and BMD are pathologies due to mutations inside the dystrophin gene. And so it is, I mean, it is impossible to reproduce the corresponding protein, or as in the case of BMD, to reproduce it in reduced quantities and in ways that are different from those who don't have such disease. So the muscle is more fragile, and so micro fissures are formed in the cell. And so huge quantities of calcium enter the cell and induce cell death. So they degenerate and they are replaced up to a point. But then as time goes by, also due to a chronic inflammation, the contractile tissue is replaced by fibrotic and adipose tissue. When the gene of dystrophin was identified in 1987, and since then researchers all over the world try to look for tools to try and imagine possible therapies. And among them, over time, well, of course, gene therapy. Gene therapy is a strategy that was hypothesized in the 70s when there were technologies enabling us to work on DNA, but of course that required a very long time. What is the objective? Fighting a disease, but not treating its symptoms, but rather going for its genetic basis. So we must provide a healthy pair of the defective gene, the therapeutic gene, a gene that can compensate for the malfunctioning of the cells. In DMD, this means that the goal is transferring our dystrophin gene inside all the muscles of our body. So this is the first problem that researchers had to consider, because we have muscles everywhere and we must find a way to transfer the dystrophin gene in all these muscles. And that comes from AAV viruses. And viruses are very good at entering cells. And some viruses that are called the adeno-associated viruses, or AAV, are predisposed for muscle tissue, which means that, well, by themselves, they enter myocytes. What is the trick? Removing the genes of the virus and transforming AAV into a vehicle where we can insert what we want to transport and have a product for gene transfer. But the big problem, there was a big problem for researchers. So there is a problem of incompatibility between the dystrophin gene and AAVs. They are microscopic, they are very small, and the same goes for the AAV virus, and it cannot contain more than 5 kilobases of DNA. The dystrophin gene, even if we try to reduce it to its minimum, we have 14 kilobases. So this is the situation where there is no possibility of inserting the gene in our vehicle, in this AAV. So this was a big challenge for researchers, but researchers realized that was a challenge we could take up. And the certainty was there in 1991 when studying a BMD patient, who realized that this patient had a mutation in the dystrophin gene that cut almost half of it. And this patient was a patient that had a very minimal pathology. And so researchers understood that it was possible to shorten the dystrophin gene, obtaining obtaining a protein product that could still be functional. So we started developing smaller forms of dystrophin, what we call mini and micro dystrophies, and that started in 1997, and we tried to optimize that, so identifying many forms, and we selected the most promising ones that are here on the cartoon. And at the end, in 2017, 2018, the first clinical studies started, studies precisely of gene therapy. So our journey in gene therapy is a journey that started a few years ago, but it has its own limitations and still unsolved problems. When the virus reaches the muscle cells, it releases the dystrophin gene, this small dystrophin gene in the muscle, but we don't know for how long this gene can go on producing dystrophin, because the children in the meantime grow, the muscle grows, and so the gene gets so is sort of diluted. So this is an unsolved problem. And then second question, when are we to administer that? Earlier, later, what age? These are just as many questions that need an answer. Another important problem has to do with our immune system. Gene therapy is defined as a one-shot therapy. You can do it once, but it cannot be repeated with the same gene therapy. Why? Well, because it is recognized as a non-self, as a foreign body. Our system doesn't know we want to do something good. So it produces antibodies. Antibodies that would be ready to attack this intruder if it were to come in a second time. So all those patients that in their life had a contact with the same AV virus being used for gene therapy cannot receive gene therapy, because since they already have pre-existing antibodies, even if we were to treat them, the treatment would be ineffective, because our product would be recognized and immediately eliminated. That's it for the introduction. And I hope I've given you the main information to better understand all that you'll be listening to during the session. And now I give the floor to another speaker, and that is the one by Professor Eugenio Mercury. He is a very well-known person for many families, for ourselves, but also at the international level among researchers. He is a neuropsychiatrist at the Gemelli Institute in Rome, and he will make an overview of the preliminary results that are gradually emerging that have been gradually emerging over the last few years. And thank you. And I give the floor to Professor Mercury. He's in a genetic wood, I think. Okay.
In the first place, thank you. It is a great pleasure for me to be here and attend this session, because gene therapy is probably what we mostly deal with to families and the children that come and see us or that call on us. And this is a task that I very willingly perform, the one of sharing the preliminary results. But I would also like to say that we didn't publish much yet. Those are the very early results that have been made available so far. But together with them, I will also elaborate on the last slide of Fernanda, trying to focus on the questions that I receive on a day hospital setting that I receive from all families as to the choice of a possible gene therapy. Now, here are my disclosures. Fernanda has already well explained what are the difficulties in coding such a large gene, such as dystrophin, for a tiny vector. So I'll skip this part. Now, I'll talk about the different approaches. Nowadays, we have the extreme luck of having almost all of the available approaches and their own respective speakers. So we will hear today all of the representatives, the testimonials of different companies who are busy today with us. And as Fernanda was saying, gene therapy is extremely promising. Maybe this is what gets the highest focus of all. But there are so many open questions still, which are mostly connected to the fact that the approach, as we know, was surprisingly effective also with other diseases. We have been involved with muscles where the gene therapy was very much successful. But the point is that the results are still limited to very restricted groups. We already have ongoing larger studies, and let's hope that very soon we will get out of those results more results. The preliminary results that you'll see, as I said, are preliminary ones. You shall hear more from the other speakers. What I did is a very quick summary just to make you understand what are the data available. Let me start with the Pfizer study. This is the overview of the program, which you shall then later on see, and is going to be illustrated by Beluscio. And that is a first 1B phase study, still ongoing, as you can see, with the ambulatory children aged between 4 and 13. Then there is another larger study ongoing, which also sees Italy as a participant, and Beluscio will then talk about it extensively. I will only show you, as I said before, the preliminary studies, phase 1B studies and the results, preliminary studies, having to do with changes occurring in the baseline in the course of a year, according to the NSAA scale. Here are the blue dots, that is the 3 low-dose children, and the red dots representing those children receiving the higher dose. And they're very recent one. In the first chart, you will see some bluish box showing the natural history. This is what happens to children aged 6, 7, 8, 9, 10, 11 years in the absence of a treatment, which is not the one that we currently use. And we see that in the natural history, we then see that the no star is not stable, but it loses some points that are different and may change according to the ages, whilst in the red dots, we see the response depending on the high or low dose of the gene therapy. The 3 boys taking the highest dose, which is the one that we use also in the next studies, get better results with respect to the ones getting lower doses who are very young. And this is also what we can see in the other chart on the right-hand side, because if we then check the curve of changes in the general population showing gray bars, we then see that the average of the loss, which is of -4 up to -6 points, and the treated children instead tend to depart from this average loss, especially the ones getting red dots that fare better and that sometimes even gain more points. So data need to be carefully interpreted, but they also show us that although we see that the efficacy is undoubted, that there are some doubts in the baseline level, but also in the higher dose. This is the next approach, the one that is almost reaching Italy. Soon it will be available in Italy. This is a partnership with Roche and Sarepta. This is the Deland Estrogen Moxaparvovic study. The first study was the study 101, and that was an open label trial, which gave the evidence that in biopsies that we saw copies with vectors of muscle cells and nuclei, and there was also a reduction of the sarcoglycan that was at the sarcolemma level in all 4 patients, and that was shown in the biopsy that was conducted after 3 months, and the profile was equal to 7. Those are very interesting data because they are long-term data. This is something that we tend to repeat over and over again to the families whenever we discuss with them gene therapy, and when we talk also about the other trials having the goal of increasing the dystrophin production. And I would like to say that this approach, the long-term approach, is much more promising than the one rather than the one that we expect seeing in the short term. Now, the results show that in the 4 patients, there always was a baseline increase, which is very important, taking into account the fact that in the time lapse of 4 years, the possibility of losing points increases with the increasing of the duration of the follow-up. And so we would expect that at 3 years, we could lose some points, especially with children that start in a relatively short period. Now, the data show how in all cases we observed an increase, but there was also variability with values that may range between +4 and +12 with different trends. There was in some children an initial increase that stayed stable. Then we saw that in other cases, such as patients 2, 3, and 4, were displaying a progressive increase in the course of time. Now, once again, efficacy was proven in all cases, but some variations. And here again, we see something else that is very incredibly good. And here we see the possibility of looking at the microdystrophin expression, which was also displaying a remarkable increase. Here, instead, what we see are the part 1 results of 1021 study. They were published in a press release, and then they were also presented in the month of July by the European Academy of Neurology. And the results were showing clearly a difference between the drug and the placebo. It was more clear whenever we would split down and break down patients on the basis of age groups in between 4 and 5 and 6 and 7 years of age. We know that maybe those are only preliminary studies and results, but they were stressing the fact that we have to be very careful at the level of inclusion or enrollment, because that's where we see the highest variability, and there is also the possibility of also having some background noise. And some kids are starting at the level of a high disadvantage situation already. Now, whenever we break down the results, dividing children in between age 4, 5, 6, and 7, we see a remarkable difference in between the two groups for 5 and 6 and 7. And then we also see the difference at the baseline level before the beginning of the treatment. Here are other results, preliminary results, showing the Ignite study, phase 1 and 2, that was conducted so as to measure and assess the safety and the efficacy. And this was also indicative of how the side effects such as nausea, vomiting, fever were possible. And we also noticed that the patients were showing some improvement in all scales in the Force-Right, in the 6- star, and in other respiratory functions. And again, the confidence intervals did show some variability as well. But those results, as a matter of fact, I was showing them very quickly, but all of them are studies involving very limited numbers of patients. The studies are faring towards the direction that gene therapy comes with ease of administration, and to the difference of other treatments and therapies, we do not have weekly repetitions in terms of therapy, and that the results are highly promising in terms of efficacy, although they raise some questions and doubts. And I did try to show them in some slides, because this was based on what families ask us whenever they call on us in the hospital. Now, why did we see so much variability? Then how to interpret the responses in different groups of age? And we've seen that the attention to break down and to layer patients may entail a better understanding of results. It could also allow us to better understand what are the expectations in the different age groups. This doesn't mean that drugs are appropriate for a very limited group of age people or age patients, but depending on the age group, as we see, there may be the use of steroids made. And the steroids may represent a variability. The age, the type of mutation is also another variable. And this is what may interfere with the expectations in terms of efficacy, of what we may expect in terms of efficacy. As Fernanda was saying, we are having worries as to the durability of the effects, the period that the effects may last. So we know that there are some gene therapies that show that after 5, 6 years, we still have good results, but the mechanism in that case with the SMA is different. The target as well is different. In this case, we have muscles. There we have the motor neuron. But in other cases, with other studies focusing on other diseases, the gene therapy seems to be promising. But nonetheless, this has to be looked in the broader context in terms of the muscle being the target of the therapy. But the questions we get from families, while bearing in mind the possible risks of side effects and also bearing in mind the fact that in the very moment when a child is enrolled in a gene therapy study, that's something that will not be modified. It stays there forever. And this is no longer conducive to the possibility of access other studies. And the use of using gene therapies in terms of improvements as opposed to other studies that are ongoing and which may entail the advantage of the fact that when you discontinue the treatment with studies of non-gene therapy, that could allow for a washout which would then allow the patients to access other studies should they ever want to or ever be eligible. And then, as Fernanda was also saying, when to intervene. Should we intervene with very young children where the muscle is better preserved, or with older children having a better developed skeletal muscle or structure? Then we also have other open questions having to do most of all as to when the results are visible. We know that many studies by using antisense oligonucleotides, well, what we learned from them is that the responses may better be evaluated with the duration of the follow-up. At 1 year, the response is visible. At 2 years and 3 years, we see that the decline is reduced as opposed to the natural history. And I think that the difference is that the natural history increases with the increase of the follow-up period. So there are many more questions. And the reason why we decided to show the questions at the beginning rather than at the end, at the time of question and answers, because this is what may guide families in the very moment when they listen the different presentation to maybe not be so critical, in the sense of rather starting wondering and asking themselves some questions, thinking of what to ask next to the speakers. Now, this is my last slide. After this, I would like to pass the floor to Fernanda and Filippo. Thank you, Professor Mercury. I think that the presentation was extraordinary for all that you said, for the stimuli that you gave us, because they led us to reasoning as to the gene therapy. And now I would like to allow for the updates, allowing for researchers working in the companies. Beppe Lucio will be the first one.
And they'll be speaking about their program of development with gene therapy with mini dystrophin. The name is very difficult for that Estrogen, Moxaparvovic.
Thank you, Fernanda. I'm Beth Beluccio. I'm the Global Clinical Lead for Rare Neurology at Pfizer. And I really appreciate the opportunity to come and share a little update about our gene therapy program for Duchenne muscular dystrophy. Of course, I've had disclosures, but what I really want to describe, as Professor Mercury already said, is that we have 4 different studies in our program to investigate our gene therapy for the treatment of people with Duchenne. We have our phase 1b study, in which we've dosed both ambulatory and non-ambulatory participants. We have a phase 3 study for ambulatory participants who are between the ages of 4 and 8 years old. We have a planned phase 2 study for early symptomatic Duchenne boys between the ages of 2 and 4 years old, and a planned phase 3 study for non-ambulatory participants. In our phase 1b study, we've treated 19 ambulatory participants, and at the upcoming MDA Clinical and Scientific Conference in March, we will be presenting our 1-year data from these 19 participants. We're very encouraged by the data. We have robust mini dystrophin expression, functional motor data that we'll be sharing in March. As Professor Mercury described, our participants range in age from 8 to 12 years old at baseline, with an average of 8 years old. And that's an age range in which patients typically experience considerable decline in their function. So our data are important in supporting the benefit not only for 4 to 8-year-old boys, but also for the older ambulatory boys. Safety data from our phase 1b study and from our phase 3 study are frequently reviewed by our external data monitoring committee, who agrees that the safety profile of our Duchenne gene therapy right now is manageable, especially with the risk mitigations that we've put in place for the ambulatory population. So considering our favorable benefit risk profile, we do have confidence in continuing with our ongoing phase 3 Ciprio study. And I'm going to give a few more details about that in a minute. But before doing that, I do want to provide some more information about the very sad news that we shared in December last year about a non-ambulatory boy who passed away in our phase 1b trial. This, of course, was a difficult thing for everybody involved. Everybody going into a trial for gene therapy does it because we all want a better life for these kids with Duchenne. So, the kids, their parents, the doctors, even people like me who got into this work because we want to help people, we want to make something better. It makes it very difficult when something like this happens. Even though I think people going into a trial understand there's a theoretical risk, when it really happens, it's a shock. Now that we've been able to look at all the information about the case in detail, we do believe that this is a very unlikely thing to happen. In the case of this child, he was admitted to the hospital within 1 week of his gene therapy, and he had signs of heart failure and dehydration, and unfortunately, very rapidly. He was the first person in our non-ambulatory group to be treated with a drug called Rapamune, also called sirolimus, along with the steroids, as part of an immunosuppressive regimen that we were exploring in this protocol. We also have recent evidence that he had an active viral infection, and we're currently investigating how that may have contributed to his death. It's important to note that the Rapamune was being investigated in the phase 1b study, but it's not part of our ongoing phase 3 Ciprio study. We've shared information about the circumstances of this boy's death with all of the sponsors who are conducting gene therapy studies in Duchenne, so that we can help safeguard the safety of all participants, both current and future, and we will continue to share information as we learn it. One thing I want to underscore is that this event, this death, is different from the SAEs that we've described previously. So in the middle of last year, we described some SAEs involving muscle weakness and myocarditis, and those are due to an immune response against the mini-dystrophin gene protein, and that happens in just a small fraction of participants with very specific mutations in their dystrophin gene. And there's no evidence that that type of reaction happened in this case. Also, the findings in this case do not follow the pattern that we've seen with complement-mediated events. And in reviewing all the data, we continue to believe that the risk mitigations we have in place, like an increased steroid regimen and also very careful observation of participants in the first 14 days, are sufficient for reducing the risk of the complement-mediated events. When the death happened in December, we did place both our phase 1b studies and our phase 3 study on pause, just for enrolling and dosing, so we could assess the case and review all the data. We've now done that. We've reviewed the data, internally at Pfizer with experts and with our external data monitoring committee. And everyone agrees that our gene therapy continues to show a great deal of promise as an important treatment, and that the data shows the potential for benefit. So it is agreed among everybody that it's very important that we continue our work to develop this drug, which is, again, an important hope for patients with Duchenne. Of course, at the same time, we need to continue to learn about the risks and to minimize them. So we've agreed with our DMC on some additional mitigations we're putting into our phase 3 study so that we can move forward with enrollment. With regulatory population, we're still discussing the steps that we need there. We do believe that the potential of gene therapy to provide benefit is true for all patients with Duchenne. And so we want to continue to develop our drug for the entire population. But we know that people with more advanced disease may be more vulnerable to certain kinds of risks, and so we want to take care and proceed in a very safe way. So right now, our phase 1b study will remain paused while we can put into place the appropriate steps there. So now I want to tell you a little bit more about our phase 3 Ciprio study. We have taken several steps to move that study forward because we believe that's very important to do quickly. We have updated our study documents, including the informed consent, to clearly communicate about our fatal event and the risk of heart failure to doctors, patients, and their families who are already participating or who are considering to participate in the study. We've also added some mitigations to our study protocol in agreement with our external data monitoring committee, taking a conservative approach to reducing risk. Protecting patients is extremely important to us at Pfizer, and we would rather be overly careful, even if in the end some of these measures are not really necessary. So the protocol and the other study documents will be reviewed by the regulatory authorities and by the ethics committees that are associated with the sites. The sites will be open for enrollment as soon as they receive approval from these authorities. And the timing of when the study sites will open will vary from site to site, depending on when they get this approval. So it's best to be in touch with specific sites near to your home to get the details of when they will be ready to enroll. But we're very excited that we have 30 sites activated around the world in 11 different countries, of course, including Italy. And we also anticipate being able to reach alignment with the FDA soon so that we can open some sites in the US as well. All the patients who have received treatment are continuing to be seen at the study site and come to their visits. And I'm pleased to say that everybody's doing very well right now. So in conclusion about our data and about these safety events, we are very encouraged by the data that we see coming out of our phase 1b study. It really supports the potential of gene therapy to provide benefit for older ambulatory patients and for non-ambulatory patients. And so we're focused on starting again to enroll in our phase 3 studies so that we can complete that and provide a robust data set for our application for market authorization as soon as possible. So then I just want to end by acknowledging all the patient advocacy groups who are so wonderful in supporting the community and patients and families as they think about clinical trials and these new therapies, and especially to acknowledge the study participants and their families, because we understand how difficult it is to take on participation in studies, and we really appreciate it. So I'll stop there, and I think we have questions at the end, I believe.
Grazie mille, grazie a Beth Peluccio di Pfizer per questa presentazione e per essersi soffermata su gli aspetti anche di sicurezza. Adesso diamo la parola
Thanks for having dealt with the safety aspects, and now the Roche representatives will now be talking about the gene therapy approach with Deland Estrogen and Moxaparvovic. This is a highly complex name developed by Sarepta, and that is in partnership with Roche. So you take the floor, and we only have a recommendation. Please stick to the time that was assigned to you because we are slightly late already. Many thanks for this kind introduction. Many thanks for the kind invitation. To me, it's a pleasure today to be here and present the development of the clinical program of the estrogen Moxaparvovic. This is a very experimental method, and it entails the collaboration between Roche and Sarepta. A very quick disclaimer before going on. You will see all of the different pieces of information that are going to be provided today that are the result of a partnership between Roche and Sarepta. Today with me, we have also the Sarepta colleagues and the Roche colleagues who will then answer the question during the question and answer session. Sarepta Roche, as we said, started a collaboration in 2019 with the objective and the goal of allowing the highest number of DMD patients to have access to a new therapeutic alternative. And obviously, we had to face all of the different aspects having to do with clinical competences, developments, the regulatory and commercial and marketing aspects were also dealt with. In the next 2-3 slides, I will be just proceeding very quickly because most of what is in there has already been said. Why the gene therapy in the first place for Duchenne? Well, because the known cause is residing in a single gene, and as we know, there may be some shorter possible versions of that gene and of the protein that allow still for the ability of it being conformed and still playing a role and a function. And the objective then and the goal is the one of allowing for some genetic material that can code for the shorter version of the protein and deliver it inside the muscle cells that are affected and involved. Here we see 3 important aspects: the transgene, the genetic material that codes for the targeted protein, in this case is known as microdystrophin, then the promoter, which is a sort of switch that has to turn on the ability of this genetic material to then be expressed and translated in the appropriate target tissues. In our case, it's muscles. And then the transporter, which is the vehicle that transports the material and allows it to be delivered to the tissues, such as muscles in this case. In the case of gene therapies, as we have already said, the vector which is mostly utilized is based upon the viral vector known as adeno-associated virus, which is not going to provoke any condition, but it comes with the advantage of allowing a very low neurogenicity and will not trigger any immune response. And as we have already said, in the case in which patients had already been exposed to gene therapies with this viral base or vector, or exposed to this kind of viral vectors that are present in the environment, and these patients would most probably have already developed the antibodies, which may stand as a non-eligibility character to participate in the testing of this treatment. Now, going to the Deland Estrogen Moxaparvovic gene transfer, which is the experimental therapy developed by Roche and Sarepta. The goal of this therapy is the one of allowing the gene that codes for the dystrophin and deliver it within or inside the muscle tissues. The treatment is administered in a single dose through infusion, that is IV injection, and it is enhanced because this allows for the therapeutic long-term effect, and its potential is also the one of becoming a future therapeutic option for a larger group of patients and population of patients with DMD, because it is not specific for those selected mutations. This in summary, is the clinical development program of Deland Moxaparvovic. Here we see the ongoing studies and the ones that are either enrolling or that have already come to the completion of the enrollment. The first study was 101 for patients, the one that was shown by Professor Mercury at the beginning of this session, then followed by another study, 102, which instead is a study that was enrolling 41 patients randomized versus a placebo. Here again, we've heard about some results of this study. And then what followed was study 103. This is the first study that was conducted with a commercially representative material, i.e. a material that was formulated so as to maintain its own characteristic also in a future industrial situation. And then another study that was also involving 38 patients that are totally different, all of them aged more than 3 years of age, and that are falling into the cohort number 4. Then study 301, phase 3 study, which will be enrolling 120 patients. And here I will delve a little bit longer with the following slides. You can see in the lower boxes, you see those are the gray boxes showing the characteristics having to do with the mutations, whether eligible or non-eligible for the different studies. And you can see that the characteristics change because as we generate new evidence in the program of clinical development, we also tend to fine-tune the protocols of the different studies, thus attaching a highest priority, which is the one of allowing for the safety of patients. Patients that as of today have been treated within this program of clinical development, and the total number is almost 80. Coming to the details of the phase 3 study, the 301 Embark study. This is a study that comes with the primary objective of assessing safety and efficacy of Deland Moxaparvovic in patients aged between 4 and 7 at the time of screening, and that at the time of screening already still are ambulating. And they will be then randomized in 2 different groups. One group will be receiving at the beginning of the study an infusion with the experimental gene therapy. The other group will receive the placebo instead via an infusion. After the 52 weeks of the first part of the study, the 2 groups are going to be reversed. And the patients that previously received the gene therapy will then receive at the beginning of part 2 study the placebo, whilst the patients that in part 1 received the placebo will then receive the gene therapy. And they will still stay for 52 more weeks in the follow-up stage. Then there is a subgroup of patients receiving a biopsy at the week number 12. Now let me come to the details. That is the inclusion criteria of the Embark study. As regards the study, the individuals that were non-eligible for the protocol are the ones having exons 1 to 17. So any mutation affecting exons 1 to 17. This is because the mutations having to do with any such exons 1 to 17 have got to do with the safety profile. And we are still studying some safety signals that emerged at the time of the clinical development study with respect to this group of patients. So for cautionary reasons, we decided not to consider them eligible, while as patients having the mutation of exon 45, the reason in this case is linked to the profile of the progression of the condition shown and displayed by these patients, which appears to be a bit more moderate as opposed to the rest of the population. So the Embark study entails with the primary objective, which is the one of assessing the efficacy. And given the fact that the objectives can be attained in the studies only if we enroll, as we saw at the beginning, a population which is as homogeneous as possible, we decided to exclude this subpopulation of patients. The Embark study entails the primary objective, that is the efficacy one. And in specific terms, this is a change whereby one goes from baseline at week 52 to the non-star scale, the North Star scale, which is then one of the secondary most relevant objective At week 52, the number of skills that are attained or improved according to the North Star scale are assessed. And then the secondary objective is also the biological one, which is measured at week 12, which has got to do with the microdystrophin expression. The Embark study is an international study, very much active already in the United States, soon in Europe and in Asia. For the study, we will not reactivate the relocation, the international relocation of patients because of the pandemic situation, which is still ongoing worldwide, and because of the need for participating studies of allowing for the collection of data in a punctual long-term manner. And this will then weigh on patients and on their own families. So this is the reason why we thought that we would not activate this program of international relocation of the patients. Anyway, the participation to this trial by means of any other trial, apart from being agreed according to the protocol, is something that is up to the participants and the investigators. Now, I think that I have finished with this slide. And I would just like to take the opportunity to thank you, to thank most of all the patients, their families, the participating families, and that are still involved in the clinical development program, as well as the entire community, which is also involved in improving and enhancing this research. Thank you so much. Thank you, Valeria Lovato. And we now switch to the next speaker.
Ghici, che è vicepresidente senior e responsabile dello sviluppo clinico di Solid, che ci darà un aggiornamento.
Roxana Dionisa Gredici will be speaking about the study of gene therapy with microdystrophin SGT-001 Ignite DMD.
Just 1 second. I cannot share. I'm sorry, just 1 second. Give me 1 second.
Sharing, you need only to go on presentation on slideshow mode.
We do see your screen, yes.
Perfect.
Perfect, thank you.
Wonderful.
Ciao a tutti e grazie per l'opportunità per il project di parlarvi di Solid oggi. This is all my Italian, so now I switch to English. My name is Roxana Dragic. I am the head of clinical development at Solid, and I would like to talk to you a bit about Solid and SGT-001. We will be having some forward-looking statement in today's presentation. You've already seen this type of slide in every other presentation today. As many of you already know, Solid has been founded by our CEO, Ilan Ganat, his wife, Annie, and a few other partners in 2013, after their son, Eitani, was diagnosed with Duchenne muscular dystrophy. Because of this personal connection, the patient experience is especially important to us, and we collaborate very closely with the patient community and many experts in the field. In 2016 and 17, we established our focus on gene therapies, and we created our lead candidate, SGT-001, and built a meaningful preclinical package. Then in 2018 and 19, we initiated the Ignite Dmd study, and we dosed our first 6 patients in a dose ascending study. Then in 2020 and 2021, we have released our first clinical data, and we formed new collaborations that leverage core areas of expertise to broaden our reach in Duchenne and beyond. We have come a long way, and I am excited to talk to you about the progress we have made and what's to come throughout the year. Now I want to take a deeper dive into SGT-001 and the Ignite DMD study. This slide provides a short introduction to Duchenne that I don't need to spend too much time on because everybody has already heard that several times during the conference. But I want to show you our approach to deliver a functional shortened version of the dystrophin gene known as microdystrophin, which you can see on the bottom half of this slide. Our version of microdystrophin is differentiated because it retains key dystrophin functional domains and also includes our proprietary nNOS binding domain, which is associated with preventing muscle injury. Now, a few words about the Ignite Dmd study. When we originally designed the study, it was a randomized control ascending dose trial, but then we subsequently modified it to an open label, non-randomized design. The study population and the entry criteria are listed on this slide, and the primary endpoints are safety and changes in microdystrophin expression levels in muscle biopsies as assessed by Western blot. To date, we have treated 9 patients with SGT-001. Our 9th patient was safely dosed in November last year. First 3 patients were on the low dose, and all subsequent 6 patients have been on the high dose. And we plan to dose all additional patients at the dose of 2E14 vector genomes per kilogram. Now I'm going to talk to you a little bit about safety, because of course it's our #1 priority and it's the primary outcome of the Ignite Dmd study. To date, the most common drug-related adverse events were nausea, vomiting, and fever, all of which appear in the days immediately following the gene therapy administration and are of course not unexpected with such a treatment. We also saw complement activation in all treated subjects, resulting in 3 serious adverse events, all of which have fully resolved. We continue to monitor all our patients that continue to do very well, going now to up to 3.5 years after dosing. Here I would like to highlight the work that we've done over the 18 months, taking multiple steps to enhance patient safety. We have worked very closely with our own data safety monitoring board, experts in a number of related fields, including Duchenne, gene therapy, and complement activation. Most recently, we have introduced an updated risk mitigation strategy, prophylactically administering eculizumab to inhibit complement activation, and we have increased our post-treatment patient monitoring. We also introduced a second-generation manufacturing strategy that reduces the total viral load by nearly 50% while ensuring high product quality. We did that by eliminating nearly all the empty capsids from the drug product. Now I would like to share with you efficacy data from our patients treated with SGT-001. This slide, you've already seen quickly in Professor Mercury's introduction of this session, shows the ambulatory function assessments for patients 4, 5, and 6 in Ignite Dmd study. You can see the 6-minute walk test and the North Star data, which is compared to published natural history study as well as our own age match control. What we can observe here that in the both 6-minute walk test and North Star assessments, our patients in the green line are seeing a general stabilization compared to natural history out to 1.5 years post-dosing. On this slide, the data demonstrate consistent improvements across pulmonary function tests compared to baseline and again to natural history. This is particularly important because pulmonary function impacts all Duchenne patients, and patients often succumb to cardiopulmonary failure as muscle cells in the diaphragm and the heart deteriorate. At 1.5 years post-dosing, patients in Ignite Dmd saw an average of 16% higher forced vital capacity compared to natural history and nearly 19% higher peak expiratory flow when compared to natural history. Finally, on slide 14, we take a look at the patient-reported outcomes. PODCI is a validated outcome using questionnaires that are completed by patients, parents, and caregivers and try to capture day-to-day outcomes and behaviors. Again, we saw improvements in patients 4, 5, and 6 that support the potential benefits in an ambulatory and pulmonary functional assessment that we just saw in the last 2 slides. When compared to natural history, patients dosed with SGT-001 scored an average of 18.6 points higher on the POTSI scale, covering a wide range of activities from transfer, basic mobility, sports, and the like. So to summarize, this is early data, but it's very promising, and we think our drug is definitely working. Now, I would like to talk to you about the future. Ignite DMD is, of course, the foundation of a very comprehensive and integrated clinical development strategy for Solid's microdystrophin portfolio. So we continue to dose younger ambulatory boys in the Ignite DMD study, while we're also evaluating other studies in older ambulant, non-ambulant adolescent and adult patients. We're also, of course, planning actively for our registrational study that will serve as a registration in US and EU. We are also planning a natural history study, which will add to the clinical understanding of Duchenne, and we're also doing active work to explore alternative immunosuppression strategies for future clinical studies. Now I want to talk to you about SGT-001. As you can see on this slide, we are leveraging learnings from SGT-001, and we now package our differentiated microdystrophin with the nNOS binding domain in one of our novel capsids, which when compared with AAV9 has demonstrated increased biodistribution to the targeted muscle along with decreased levels of expression in the liver. This is SGT-003, our next generation microdystrophin. Of course, the goal remains to increase delivery to the muscle while reducing the total viral load and the overall immunological burden. Mice that received SGT-003 with this novel capsid had significant increases in biodistribution to the targeted muscle with decreased levels expressed in the liver when compared to mice treated with AAV9. These improvements correspond to similar increases in actual microdystrophin expression evaluated by immunofluorescence. As you can see, mice dosed with the novel capsid also have the lowest CK levels, providing evidence of increased muscle stability. IND-enabling studies and manufacturing activities are well underway, and we will begin discussions with the FDA this year to support an IND submission early in 2023. I want to close by reiterating our catalysts for 2022 and beyond. SGT-001 remains our top priority. We will continue dosing more patients with the goal of closing the Ignite DMD study this year and to enable an end of phase 2 discussion with the FDA. We look forward to releasing additional biopsy, clinical and functional data from Ignite DMD. We also plan to move aggressively with our next generation microdystrophin, SGT-003, to an early 2023 IND submission with the release of additional data as well as pre-IND discussions with the agency. And we will continue leading, of course, meaningful community discussions, such as the Pathway Development Consortium that we launched with Regenex Bio last year. These type of public-private collaborations are important to the entire field, and they help us create healthy dialogues to better understand and more successfully advance therapies for patients. We are very glad to be part of such an effort. Thank you very much, and I will be taking questions at the end of this session.
Grazie mille Roxana per il tuo intervento, grazie anche perché vedo che ci state aiutando a recuperare il tempo e quindi adesso è con molto piacere che chiedo...
Thank you for recovering and making up for the time. I would like now to watch the pre-recorded video, and she will be talking about the gene therapy that they are developing. So thank you to the control room, and let's now watch the video.
Hello, everyone. My name is Olivier Danos. I'm the Chief Scientific Officer at Regenex Bio, and I'm happy to be back here this year to update you on our investigational gene therapy for Duchenne muscular dystrophy. Those are my forward-looking statements. A few words of introduction on REGENXBio, who we are. We're leaders in adeno-associated virus, AAV gene therapy. We're a company founded in 2009, and we're headquartered in Rockville, Maryland, in the USA. We have a technology platform of over 100 different vectors. Some of them have been licensed to partners who develop gene therapies in a broad range of therapeutic areas. One of these treatment is now available on the market as a treatment for spinal muscular atrophy called Zolgensma. We have developed capabilities in developing AAV gene therapies in-house, and we also have manufacturing facilities. And we're very happy to be able to leverage all this and propose today the development of a gene therapy treatment for Duchenne muscular dystrophy. This is our pipeline, and what you see at the top is our GX202, which is now officially part of our clinical pipeline since we received the green light from the FDA to proceed to the clinic, and we're going to, our goal is to dose the first patient in the first half of this year. So our product is called RGX-202, and it's an AAV8 vector. We've chosen the AAV8 capsid because we know it's very efficient at transferring genes into the skeletal muscle and the heart muscle. It's also been utilized in numerous clinical trials, and we have the capability for making large-scale production of these vectors. In the AAV8 capsid, we package a recombinant genome of AAV, which is shown here on the right side. And this genome encodes for a microdystrophin. The microdystrophin is expressed from a muscle-specific promoter called SPC512. And this microdystrophin is a bit different from those which are currently developed in the clinic because we've added additional information to the protein. We've added the green part, which you see here on the right side, which is an additional region of the C-terminal domain of the protein. We've also made a number of modifications to the vector, a number of improvements, reducing the CpG content for minimizing immunogenicity, and we optimized the codon for optimal protein production. So this is, again, focusing on the C-terminal here. Again, the green box at the end of the cartoon here that represents the microdystrophin. The C-terminal altogether is an important part of the protein because it acts as a hub that attracts a number of cellular proteins that forms the dystrophin-associated protein complex. And this complex plays a number of roles in maintaining muscle function and recovering the muscle ability after contraction. By building an elongated C-terminal here, the goal here is to obtain a more potent microdystrophin. And so this is what we embark to do, and I'm going to show you some data on how we think it works. This slide just tells you what we've done in terms of preclinical development. Initially, we've tested the activity of this novel microdystrophin in the MDX mouse. And we've looked at how efficiently we could transduce the muscle, looking at the DNA across different muscles, including the heart. We've looked at microdystrophin expression, and we've looked also at the recruitment of the dystrophin-associated protein complex. Then we've studied the amelioration of muscle pathology, reduction of dystrophic lesions, and we've also measured functional improvements in terms of strength and gait analysis. This slide is a summary of some of this data. On the left side, at the top, you see the result of measuring dystrophin, microdystrophin in MDX animals that were injected with increasing doses of RGX-202. As you see, there's a nice dose response. As when you start increasing the dose, you see more and more dystrophin. The levels of dystrophin that we make are eventually very high at high doses, and so that this is that's what's presented here. At the physiological level at the bottom, we see that we recover dystrophin at the periphery of the muscle fibers. And this is also, we can see a dose response in these pictures as well. When it comes on the right side to associated proteins, we also detect them as expected. Here we show the detection of syntrophin, dystrobrevin, and NOS. This is shown here in the wild-type mouse that forms a normal complex. MDX, no protein can be detected, and following gene transfer with RGX-202 in MDX mice, we recover levels of syntrophin, dystrobrevin, and NOS. This is just a selection of the protein, but the whole complex is actually being re-established. Now, if you look at muscle pathology in these MDX mice that were treated, we look at this is one example of what we did in the diaphragm, where we can look at fibrosis by staining that stains in blue the fibrotic areas. The normal animal histology here is shown on the left, and there's really no fibrosis in the normal animals. In the MDX mice, there's a lot of blue area that signs fibrosis. And again, as you dose up the vector, you see that the fibrosis disappears, and this is quantified in the histograms here on the right side. The walk test that we did with these animals also show a very clear improvement in the functional ability of these animals. The untreated animal have a very high score. This is the MDX mouse if you compare to the normal animal. And following dosing, we decrease this score very significantly. So this is functional recovery at the whole body level. Muscle force can also be measured, and this is what we obtain again: increase of muscle force from the MDX following treatment with our vector. So this is the data that convinced us that we could get into IND-enabling studies and put together a package for application for a clinical trial. We completed this. We complemented this initial preclinical data with pharmacological study in MDX mice, further pharmacological study, and safety toxicity study in non-human primates. We also manufactured the vector at commercial scale, and we've designed the clinical trial. So again, our application was positively reviewed by the FDA. We have a safe to proceed, and we are about to start this clinical trial. The next slide will just give you a bit more information about the trial itself. So this trial is called Affinity Duchenne, and this is an open label, multi-center dose escalation and dose expansion clinical study to evaluate the safety, tolerability, and clinical efficacy of a one-time intravenous dose of RGX-202. This is done in patients with Duchenne that are 4 to 11 years old. They are ambulatory patients, and those are patients also which have mutations between exon 18 and 58. There's also a request that the patient be negative for anti-AAV8 antibodies. So our primary endpoints are safety and tolerability. The secondary endpoints are microdystrophin protein expression, which we will assay at 3 months in a biopsy. We'll also measure muscle strength and assay for muscle function, and that's basically using the North Star scale. And we'll follow the muscle aspect and pathology by MR. So in this dose escalation study, we initially will treat 3 patients at a lower dose of 10 to the 14th genome copy per kilogram. And following safety review, we hope to be able to dose up to 2 times 10 to the 14, and also at the same time we would expand the first cohort at the lower dose. So this is, in a nutshell, what we are prepared to do. We are very excited and happy to be able to propose this trial. I will leave you here and tell you that for the Q&A session, my colleague Paolo Falabella, who is Vice President of Clinical Development and in charge of the DMD program, will be answering the questions. And don't hesitate to get in touch with us if you have further questions after the conference. Thank you very much.
Thank you, Olivier. And now to move on, Professor Francesco Muntoni, who's a neurologist at the Dubovitz Neuromuscular Center, Institute of Child Health at the Great Ormond Street Hospital in London, and he is probably one of the most prestigious rapporteurs in our conference, though he's very young. I am a young researcher, just as much.
Nice to for this nice introduction. Io continuerò in italiano.
Well, I go on in Italian, since I haven't forgotten Italian entirely. My presentation will concern the development of AAV8 gene therapy that Genethon is developing. These are my disclosures. I am the chief investigator of this clinical trial. And for those who don't know what Genethon is, well, Genethon is a structure that is strongly associated with the companies. We have discovery and innovation sector, so basic research for neuromuscular diseases. Then we have many projects that move from research and go towards clinical development, and in DMD, among others. And to the right, something very important, Genethon has created a strategic alliance with this company that is called Iposchesi. So the possibility of producing AAV and lentivirus. So we have that possibility in that plant. The gene product is called GNT-0004. This is the drug construct. It is an AAV. The instructions on how to make it are not very different from other drug constructs, because as in other drug constructs, you must cut and you must choose what to put in the vector, in the viral vector. So this is a truncated part of normal dystrophin. Just to give you an idea, if we wanted to put the whole dystrophin gene, we would have to increase the capacity by 2.5. And the compromise we did find was putting this portions of dystrophin. There is a promoter that is extremely active for the production of dystrophin, both in the muscle and in the heart. And we try to optimize so as to obtain a maximum expression of this virus. As in other AAVs, we have an IV infusion for about 2 hours. As for what's happening at present, there are 2 aspects of this study that I'd like to underline. We have already started a natural history study taking place both in Europe, in 4 countries, UK, France, sorry, not only in Europe, but also, well, we have there UK, France, USA, and Israel. Well, we'll be recruiting 100 ambulant DMD children. And this study aims at identifying the best time to study, the best time to intervene with microdystrophin, because an important part of this study is that the patients that will be selected are patients where the plateau has already been reached. So they must be either stable or they have started a decline of their physical conditions, to try and understand as much as possible what is the effect on that population without having the problem that you may have with very young children. So, as for the treatment, after this part about the natural history of the disease, then there will be other 2 phases. So we have dose escalation first, so at least 2 doses. So a group of children will get this dose. This dose is quite low if compared to what other studies do, and that may be one of the advantages of using AAV8. And then after the first group of 3 kids, we'll have a second group that will be studied with a higher dose. And at that point, we'll decide if that dose is adequate. And then that will be introduced through a larger study, or whether it is necessary to move forward with a 3rd dose. Animal studies indicate what are the expectations of these 3 different doses, but we must understand whether our expectations are mirrored in men as well. So once we've decided on the dose, we'll start this study. This will concern 21 children. They will receive, 21 children will be receiving the dose and 21 children will be receiving the placebo. After 1 year, you will have a crossover. So also the children who have had the placebo will receive the dose of the drug. Then we'll measure the efficacy at 1 year, but we envisage a 3-year follow-up. And for the children who had started with a placebo, of course, the overall follow-up will be 4 years. So in the first part of the trial, we'll have 6 patients that will be enrolled for the low dose and then in an intermediate dose. And if necessary, we'll have an optional cohort with a still higher dose. And these are the doses that will be used in the 3 cohorts, in the 3 subgroups of patients. And in the second part of the trial, all patients will receive the dose that we consider optimal, either immediately or after 1 year. So for the children who have received the placebo, they will be getting the optimal dose after 1 year, 1 year later. So these studies are essentially, or at least initially, to understand if the dose that is used is well tolerated, and if the dose can be given without inducing serious adverse events. And this is the first part of the study. The second part of the study, well, we must be absolutely sure that the dose that is administered is well tolerated and safe. And of course, in the second part, we want to also to have information as to the clinical efficacy that will be measured with an SAA score. The part number 3, that is the long-term project, and we want to know, we want to assess how far this treatment, to what extent this treatment is safe and well tolerated in the long term. Again, secondary objectives. First, I've spoken about primary objectives, but when we speak about biodistribution, well, that means essentially what are the levels of dystrophin that will be found after muscle biopsy, and also understanding whether there are aspects linked to immunogenicity of these for these children receiving IMP. And third part, an important aspect is, not only evaluating safety, but also long-term efficacy of this gene therapy. As for eligibility criteria, as I initially said, apart from a DMD genetic diagnosis, the strategic choice is recruiting children that have an SAA scale of 18 at least, but that are not improving. They must be either stable or descending, to make sure that whatever effect we measure is just due to the therapy. Then we have here the general exclusion criteria, so as to exclude children that may have serious problem, especially after the administration of the gene therapy. For example, children who in the past have already received an exon skipping drug or a stop codon read-through agent. Well, these children might be taken into account if they have had a sufficiently long washout period. When the protocol was developed, we were very keen on considering also what had been happening in other programs. We wanted immediate response mechanisms if we were to find problems linked to complement activation or liver problems and so on. As in other programs, corticosteroid therapy is used immediately before starting the dose. So you use a higher dose than what you normally have for children, and you go on with corticosteroids for 8 weeks. Well, this is my last slides, okay? We are running slightly short of time. The first patient, as you all know, the first patient who was treated had an important, a serious effect. After 42 days, he had what we defined a serious, unexpected, suspected adverse reaction, SUSAR. So this young boy had no special comorbidity, but he had to be hospitalized. Now he's doing much better, and so he is out of this acute phase. And this SUSAR led to discontinuing the program, the Geneton program, and at present we are trying to understand if this side effects is due to a sort of response to the transgene, as was the case in other programs. When I speak in Italian, of course, I'm a bit slower, so excuse me. Thank you.
Quindi per recuperare il tempo.
Many thanks. And now let's pass the floor immediately to our friend, Flandin Canagan, coming from the nationwide gene hospital in the United States. This is a slightly different gene therapy, but he will explain this himself. Many thanks. Now you have the floor. I can't hear you. I'm sorry. The mic probably is very far from your mouth.
There we go. Sorry. Thank you very much for the invitation to speak and to talk about something I talked about several years ago in Rome that we now have developed and put into patients. It's a great pleasure to talk. I'm disappointed not to be in Rome because in the middle of Ohio, one cannot find any good cacio e pepe. So I can't. I wish I was there. Just a few disclosures. The technology I'm going to talk about is actually licensed to Astellas Gene Therapies. Why would we start skipping? You've heard all of these great talks about microdystrophins for people with all sorts of mutations. Why did we start with exon 2 for this therapy? One reason is that exon 2 duplications are the most common duplication mutation in Duchenne muscular dystrophy. And by trying to skip exon 2, there's kind of a safety valve to the therapy in two ways. It is because in the DMD gene, there's something special in exon 5. It's called an internal ribosome entry site. I'll refer to it as an IRES. And that allows an alternate start to the translation of a dystrophin protein. So you can make an alternate version. And I'll show you why this is important for the type of therapy we're doing. And I'm going to begin that story a little bit. We discovered it because of a different exon 1 mutation, a different mutation in exon 1, but it's very highly relevant to exon 2 therapies. And the observation that this IRES works comes from finding many families that have a mutation in exon 1 that we would predict makes no dystrophin whatsoever. But in fact, we found many families who carry this. And the person we first found it in walked all the way to the age of 70 years, died at age 77 years of unrelated illness. And he makes a protein that's just a little bit smaller in size. And not that much of it, about 15% of normal levels of that protein. And even though there's 15% of this protein, it's good enough to walk to 70. So that tells us whatever is made by the IRES is actually a highly functional version of the protein. Well, why is that important to exon 2 skipping? Well, it turns out that we know that in exon 2 duplications, the IRES is there in exon 5, but it turns out that in this case, it doesn't seem to work. Patients have Duchenne muscular dystrophy, and we knew when we first started this work that there were no previous descriptions of deletions of exon 2, even though they had the IRES there, and we suspected that the IRES was active in that group. And when we studied it in a system here, the details of the system are not that important, except to say this IRES activity is what this is, how functional that element is. It doesn't work in the presence of a duplication of exon 2, but it works in the presence of a deletion of exon 2, telling us there's something about the structure when the RNA is formed, telling us that you can delete it entirely and still get this functional protein. And in fact, in Italy, at a meeting, I was saying that we expected someday to find a patient with a deletion of exon 2. And my colleague and attendee at the conference today, Alessandra Ferlini, said, in fact, she had found such a patient, and that patient had the same sort of shift, making a somewhat smaller size and essentially had no weakness as well. So how does this all tie into what we're doing therapeutically? It tells us, well, if we delete, the deletion but not the duplication results in the expression of this version of the protein. And what it means for us is that we have a very large therapeutic window. If we can skip one copy, we make an entirely normal dystrophin, not microdystrophin, but an entirely normal one. But should we skip too much, we can still make a very highly functional version of the protein. And the people who make that protein and walk till age 70 tell us that we have this big therapeutic window is how we would describe it. So how do we do that? Well, we do a gene therapy that's a viral-based exon skipping. And we use a version of RNA called a U7 small nuclear RNA. That's what this stands for. And the U7 small nuclear RNA it's a kind of RNA that never is translated into a protein itself. It can be targeted to any exon we want, and it interferes with the assembly of the machinery that has to be present to splice together a gene appropriately. So we have a version that contains we have a vector in AAV9 that contains 4 copies of this. 2 of the copies go to the splice acceptor site and 2 of the copies go to the splice donor site. And just in the past year, we've published several things showing that this is not toxic when we give it in primates, that it skips where we want it to skip. It doesn't skip at other places. And we could show that in a mouse model that has a duplication of exon 2, we can show that we can go in a dose-dependent fashion. We can establish a dose where the number of fibers gets very close to 100%. The intensity of those fibers is quite intense as well. This is a this is a picture of fiber intensity showing first dystrophin and then a way we quantify the fiber intensity or positive fibers, the number of positive fibers here in diaphragm and here in skeletal muscle. So this is where we begin our studies at 3E to the 13th vector genomes per kilogram. And I'm going to share some data from a first-in-human study. It's run by my colleague here, Dr. Megan Waldrop, and it's the first time we've put this into humans. The first 2 patients were older, 8.9 years of age and 13.7 years of age. This is a list of the sort of things that went on. Nothing really terribly unexpected. We know with many gene therapies now, there's some vomiting when you give systemic AAV9, but nothing that really is suggestive of any toxicity so far in these 2 patients. And these are measures. I'll concentrate on the creatine kinase on the right here. We saw a pretty immediate drop in the creatine kinase. And I think one of the questions that often comes up is CK a meaningful measure or not? And we know there's variability with CK in boys with any sort of dystrophin-related disease, depending on what their activity is. But these are fairly profound drops down to the level of about 500, although they've increased a little bit over time at 1 year. And this is associated with relatively low levels of expression of dystrophin on the order of, in the older boy who was much more severely affected, it was about 1.3 or 1.4%, and in the younger boy, between sort of 6 and 3.5% of dystrophin expression. And we don't want to draw too many conclusions from just 2 boys who were the first ones treated, but we can say that they remain relatively stable. So the oldest boy is treated at 13 years of age is still walking, for example, that's subject 2, and all the subjects have been either kind of stable in their North Star ambulatory assessment. You can see it's gone up by 2 points, but we don't consider measures of 2 points to be significant in the North Star ambulatory assessment necessarily. But there's stability, particularly in measures of knee flexion and extension. And importantly, both boys remain ambulant. Now, what's most exciting, well, arguably most exciting to us is we've recently treated a patient who's an infant. This is probably, to my knowledge, the youngest patient treated with a gene therapy for Duchenne dystrophy. He presented to clinic at 5 months of age and diagnosed prenatally. His mom was a known carrier. Treated at 7 months of age and did very well with our treatment. This is really relatively new news. We don't have his next biopsy, but we can see a really profound decrease in his serum CK. And one thing we'll say about an infant is, when we see changes like this in an infant, we might know that a boy with Duchenne might walk around with 2,000, a level of 2,000, and then he goes and runs and plays a game of soccer or football, and his CK goes up 5 or 10 times. But an infant doesn't have that sort of variation with activity. And these are really quite pronounced drops in the serum CK for an infant. At baseline screening, 13,000. After 30 days after treatment, a number that's really approaching normal, and it's quite staying down as well. So, oh, pardon me. So we can say this was well tolerated, and this infant gives us the ability to look at dystrophin expression when muscle is relatively intact. And because he's treated so young, we really do anticipate being able to assess durability of his treatment, which is something that's really quite important. And I'll just close by saying, although I've shown you gene therapy data, there are potential other routes to skipping this region of the gene. This is data with a peptide-linked morpholino oligomer that is designed for a sequence of ours, and the peptide is from Sarepta, who provided the reagent for this study. This paper is under review, but we can see here in the tibialis anterior muscle and in the diaphragm, we can see that treatment with a single dose of this at 15 days later results in significant amounts of dystrophin expression, here color-coded for intensity of staining of individual fibers. So we consider this promising. Our preliminary data suggests the gene therapy gives us meaningful expression. And again, what's important about this is we believe this is full-length dystrophin we're detecting. I showed you two potential routes, the full-length or the iris-driven form. Our preliminary data suggests that this is the full-length version, which we would expect to be more stable. And in the older boys, we can say there's been what appears to be a stabilization of function and clear improvements in the serum CK. And in fact, early treatment may be best, and the infant will give us some information on that. But skipping with antisense oligomers also may be a feasible route and a way around some of the difficulties with retreatment with viral gene therapies. So I'm going to close by highlighting my colleague, Megan Waldrop, some other collaborators who've been involved in the development is Adeline Verlin, Nicola Wen, and Tabitha Simmons. And I'm happy to look forward to questions after the rest of the talks.
Grazie Kevin per essere rimasto nel tempo.
Many thanks, Kevin, for staying in your time limit. Thank you for this presentation.
And now I give the floor to another very young researcher that we are very happy to see, regenerative medicine. So even if we become old, well, it'll help us regenerating ourselves. Thank you, Filippo. So as you see, I am 131. I mean, this birthday is a birthday celebrated some time ago, but as you see, I'm doing pretty well. I'll be speaking about our attempt at finding a solution for muscular dystrophy using as a drug, not the gene transported by the virus, but using the cells. It is a very long story. I'll cut it short. Some 20 years ago, we isolated cells that we defined as mesangioblast MABs. They derive from the wall of the vessels, but they can cross the wall. So if we insert them in the arteries, they can reach muscles downstream, and they can differentiate the muscle, transducing in the we tested this model in mice and dogs, and all seemed to go very well. Then we reached the phase 1, 2A. We did that with cells derived from a brother, from a sibling who had these cells absolutely identical, and we injected them in femoral arteries and the subclavia in some patients, but the efficacy was very, very low. low. It was insufficient to go forward. There were many reasons for that, but in the years after that, also for other studies, is that cell therapy works only if you can eliminate diseased cells and make room for donors cells or treated cells in tissues like the heart, the muscle is not feasible. So you must try and think about something else. Considering the patient, I mean, I'm speaking of a patient age 8. He expressed a low quantity of dystrophin, but that was sizable, and that was the best result. It was not much worse than the worst results we had on dogs. So we thought that the efficacy road was not unlimited, but it went through 3 ideas: improving, first of all, the transplant protocol so that we could get more cells in the muscle. Second, developing a strategy that could solve the problem of the colonization of the muscle, because the colonization of the muscle will stay low even if we increase the dose. We had given 1 billion cells to the patients, so it was not really a minimal dose, and improving the way in which they can cross the vessel walls and migrate into the tissue, but using MABs as a sort of Trojan horses. And all those who spoke before me, they've all spoken of in vivo viral gene therapy. So the viral vector is directly injected into the patient, but there are also the ex vivo therapy where the cells of the patient are taken, they are then genetically corrected in culture, and then they are retransferred into the patient. And that is something that could give us a tool to compensate, I mean, to avoid the obstacle, because no matter how many cells we could inject in the patient had less than 1 healthy cell per 99 cells with a disease. And of course, the muscle cannot possibly work with just 1 good cell out of 100. So we started improving the protocol, and something very simple that we had not understood early enough, that if steroids reduce the inflammation, so they reduce the expression of proteins such as VCAM and also MABs. So removing steroids, gradually eliminating steroids for 1 week before treatment, and we would have had a much better colonization. But what makes us believe that we could reach a real therapy? I mean, you have heard Kevin speaking about exon skipping when it is mediated by the viral vector. Our exon skipping is mediated by cells. So if we transduce our cells with a vector producing this microRNA engineered for the skipping of exon 61, well, that is produced in the cytoplasm. It binds to nuclear proteins and penetrates the nearby nuclei, thus amplifying the production of dystrophin. Here you see with healthy cells, there is a stepwise dilution. Here you see in a culture with dystrophic cells with genetically corrected cells, you see that even when the dilution is 1/230, you have an important quantity of dystrophin. And that is due that this small RNA travels through the myotubules in vitro and in vivo, and goes far away from the nuclei producing it. And that is why we saw a quantity of dystrophin with just one injection of human cells in the tibial muscles of immunodeficient mice with a mutation of exon 51, which is far higher than the wild type cells. And by using the dystrophic rat, the one produced by Frederic Relais, with arterial catheters, we were able to reach the diaphragm and obtain a production of dystrophin in the diaphragm that we had never seen before, because the diaphragm is a muscle that is quite difficult to reach. In order to demonstrate that all that really worked, we started a clinical study with a protocol that was suggested by Francesco Muntoni, and apart from some earthquake, I mean, just the only thing we missed was an earthquake, because everything else happened. Of course, the latest obstacle was COVID, but apart from that, the protocol had been approved, and we had prepared from the extensor digitorum brevis, we had prepared the cells that we had transduced, and with this vector, the cells, this lentivector, it was the best preparation of cells ever carried out in GMP. There was a very good differentiation, perfect karyotype, perfect pro-vector integration sites, and a lot of dystrophin being produced, no tumor formation, everything was perfect. We were ready for the injection when COVID arrived. Then there were problems for the facility. We had to find a different one. So we are starting from scratch. We are starting this trial from scratch once again, but I think we can demonstrate a quantity of dystrophin that is about 20–30%, and at present that is considered as being therapeutic. So in theory, we believe that clinical efficacy with this strategy, I mean, clinical efficacy may be reached with this strategy, and we must improve the protocol with other tricks that I have no time to tell you about. And obviously, especially for cell therapy, we should be treating patients as early as possible, and also combining other therapies to reach something after 10 years. 10 years in England. I haven't learned English well enough, but I am a bit hesitant with Italian. And then if we want to reach the heart, we must do something more. And I hope that quite soon I can share with you the results of the clinical study that is starting now. Thank you.
Ne approfitto per ringraziare lui, ma per ringraziare anche tutti gli altri.
I'd like to take advantage to thank you and all of the other participants to this extraordinary session, because while we were talking and while we were listening to the other interventions, they had already answered the many questions coming through the chat line. Most of the questions were already answered, and we will collect all of the answers and pass them on to you during the conference. And we are going to ask them to Kevin Flanagan. They are coming from Patrizia. There is one question saying, my son has a duplication of exon 2 and he's almost 15 years old and he's still deambulating. What are the possibilities that he has to get that treatment, to have access to the treatment? And the other, still for Dr. Flanagan, is the skipping, the gene skipping for the Duchenne. Can that be also applied to out-of-frame deletion, the out-of-frame deletion from 3 to 7? Those are the two questions for Kevin. Hopefully he's going to answer in a very rapid manner, and then hopefully we will have more questions to answer.
So an interesting finding about duplication 2 is, although most patients have really a classic Duchenne kind of clinical syndrome, about 20% of the patients do somewhat better, and they make use of or they eventually get called Becker Muscular Dystrophy, and it sounds like Patricio's son may in fact be in that category, and presumably that means there is some escape and some utilization of that IRAS-driven form. We anticipate that this kind of therapy will be beneficial for anyone certainly still ambulant with Duchenne dystrophy, and even may be beneficial in boys who are no longer ambulant in preserving the trunk muscles and the diaphragm muscles and so forth. In our case, exon 2 skipping for a deletion of 3 through 7 is probably not going to be significantly helpful, although it might be helpful for other mutations before exon 5 in the gene.
Grazie Kevin. C'è un'altra domanda.
Thank you, Kevin. We have another question coming from Alberto. He's asking why the CK11 is not considered, or at least it's not presented as a significant measure in most of the studies, although a reduction with respect to the baseline should per se be indicative of the efficacy of the treatment. Anyone who'd like to answer to this question?
Maybe I'll jump in because I presented CK data. There's a saying a colleague once told me that said, the CK is just not a good biomarker until it is a good biomarker, which is a little bit funny way to say it. The CK varies so much that even in clinical practice, we know that a boy can be 3,000 one day and 15,000 the next day just by the amount of activity that he did. So in general, we can look at it in many groups and see if it declines in a group over time, but we have to be reluctant. We have to be very cautious in how we use it as a marker, because in boys who are ambulant, it's very related to their walking, and in boys in non-ambulant, it also diminishes over time. The reason I think it's significant in the infant is because he's not doing that sort of activities. One of my other clinical colleagues might want to add to that their thoughts.
Grazie. In teoria abbiamo un altro...
So theoretically, we still have another question coming from Alberto. Is it possible to receive a therapy with an AAV such as AAV9 and after a few years maybe try a different treatment with a different AAV or viral vector?
Well, if no one's jumping in, I'll take. I don't mean to speak too much, but there's a concern of cross-reactivity between many of these. But theoretically, it may be possible to receive treatment with a different vector down the line. And I know many of the companies represented here probably have thoughts on that as well.
This is Francesco. I don't represent any company. I think that as Kevin says, that experiment may be a bit risky to do it, because of the cross-reactivity. The good news, however, is that a number of companies, both in the Duchenne field, but also in other fields, are investigating ways to try to reduce the initial immune response to whatever AAV is given, so that re-administration might be possible. But I think that actually one thing that is interesting is that, and this could be done probably prospectively in all the clinical trials, when a child is dosed with AAV RH74, what is the immune response against, or the cross-reactivity against AAV8 and AAV9. This would be very helpful if this was done systematically.
Grazie.
Allora, thank you. Now, unfortunately, the time available to us has elapsed. We should try and be better organized, especially next year, because it was so much nice to be late. That was done in presence, obviously, and that would allow us to talk of whatever may come across our minds. But unfortunately, here we have time limits and we can't be late. So we have to stick to the program. Now, we pass the floor to the next session of our own conference, which is the roundtable on the projects of autonomy. Anna Petruzza from the CAD Lombardy is coming. Thank you to all of the speakers. You were extraordinary. We love you. We hope to see you in presence and hug you in presence. Many thanks. Bye. once again, thank you to everybody and good afternoon. I am Dr. Anna Petruzza, psychologist and psychotherapist of the CAD Lombardy, together with my colleague Giada Perinel, that is the other half sharing with me the Lombardy CAD. We are happy to welcome you in this roundtable, which aims at digging into the process of building autonomy during the time frame, starting from infancy, the early infancy, which is allowing for the beginning or the initial steps of the project. And me and Marco are going to be more than happy to put together all of our data. Our journey will then proceed towards its second stage, adolescence, which is a moment rich in challenges and of important achievements, and Dr. Federica Corbett and Vittorio Montisci will intervene. Then the last stage of this journey is the adult age. That is when we will be collecting the results of the work that was conducted over time, and that is going to be done by Giada Perinel and Luca Michino. But the incredible objective that we would like to consider during this roundtable is to show how it is possible to build on independence and autonomy in the different life cycles by calling into the play parents, the direct involved boys, friends, and other people. And last but not least, this will be conducive to another pathway that was already looked at. And now I would like to pass the floor to Carmine and Marco, two parents who are going to help us, thanks to their own testimony, to try and understand the many challenges that a child with DMD or Becker dystrophy may be met with, and what are the resources that he may be activating whenever working on autonomy and independence in a constant way in the course of time. Please take the floor, Marco.
Buonasera. Ciao a tutti. Sono Carmine e Marco, genitori di Gabriele. Gabriele è il nostro primo figlio, è affetto da distrofia muscolare con mutazione dello stop e dell'esone 60. E questo ha comportato per noi in un primo momento delle piccole difficoltà.
This obviously posed quite a few difficulties at the very beginning, but with the help of the various associations, we were able to endure these difficulties. But our path began way before that, when I realized that our boy didn't speak. He did not respond to his name when we called him, and I became very concerned.
All'età di 2 anni e mezzo mi rivolgo alla neuropsichiatria di riferimento e dopo qualche mese viene preso in carico. Purtroppo però il bambino si evolve, cresce, passano 2 anni, ma non riusciamo a capire cosa abbia, perché quello che noi osserviamo è questo, sostanzialmente questo: il bambino va all'asilo, si muove con molta fatica, perde facilmente l'equilibrio, basta che un bambino lo sfiori perché lui cada, e questo ci mette
He would fall over very easily, and this obviously filled us with anxiety and fear.
Spazio dove non ha una sicurezza.
It's as if our little boy didn't feel sure of himself physically. As some time went on, while linguistically he started to speak, physically there was quite an exacerbation. I mean, often when he would get up, he would stagger, and he actually did a maneuver, which apparently we found out later is the one of the evident signs of this illness. The interpreter apologizes, but the sound is extremely poor. We can hardly hear. So we became extremely anxious, of course. At this point, my husband said, we have to help our little boy. We've got to take him elsewhere because a neuropsychiatrist doesn't seem to be able to determine what is going on. So we went to see a physiotherapist, a relative of my husband's, who checked all the data, observed him very carefully, and then said to us, look, a friend of mine has a daughter who has a muscular disease. And in observing your son, it seems to me that maybe these difficulties arise from that illness. I don't know what the illness is, but I know that something of the sort is involved. So she gave us the address of another physiotherapist. This time, this therapist was part of a facility, a care facility. In about a fortnight, we were able to make an appointment. We went to see the physiotherapist. The physiotherapist observed our child, Gabriele, for about 10 minutes and said, okay, your son has definitely a muscular disorder. In the month of August, we saw the physiotherapist in July, and after a month, we were able to make an appointment to see a specialist. And this specialist decided to take a blood sample. And she was able to confirm the diagnosis. Initially, she thought it was BMD, but then she said, no, it's DMD, it's Duchenne. So she talked to us and explained clearly what the disease is all about. At that point, we had a couple of reactions. On the one hand, we obviously were overwhelmed with anguish. And on the other hand, however, we were kind of relieved because we realized that something was wrong with our child, but we didn't know what it was. Often, people around us would say, oh, no, it's just that he's lazy, he doesn't want to do this. Sometimes they used slang. And I thought it was quite offensive. And anyway, I felt that they were judging us and him. So after these reactions, we adapted our life to our child's condition. I changed my working hours according to his schedule. We made arrangements in order for our house to be more hospitable to him with several devices so that Gabriele was able to move around more easily inside the house and also outside. And in order for him to be a little bit more independent, because we really did not want Gabriele to depend upon us 100%. We didn't want him to feel that he had to rely on us. We wanted him to be as independent as possible. Gabriele was almost, we felt, aware of his limitations, but at the same time, he was willing to do things on his own and move around with a certain level of certainty. The problem, obviously, was going to school. We had to obviously let him be on his own. We had to allow him to have his own friends, and that was very difficult for us. It was very challenging, at least for me, because as a mother, well, you know, culturally too, as mothers, we want to be everywhere. And we want to do everything for our children and our husband. We want to be superwomen almost, but actually that can't be. So little by little, we had to work on ourselves to make that change, to help Gabriele. I'd like to tell you a story about that. Gabriele was growing. He got to school age. We registered him in first grade. He made friends. He was happy, and obviously his friends invited him over to their place. One day, I got the phone call of a mother who said, I'd like to invite your son to play with mine. Let's organize a play date. And at the end of the phone call, I became totally anxious and very agitated because she started asking me questions. She started, or rather, my son started asking me questions. And I asked myself questions. Will I be able to let go? Will this mom be able to meet the needs of my son? Will she be attentive to him? What if he falls? What if something happens to him? Does she realize that she needs to look after him in a special way? And on top of that, I thought that Gabriele might also be a scandal, so to speak, meaning that the parent might have thought, oh my goodness, what a problem child. Why didn't he stay home with his parents? I was really, really scared of being judged as a mother. But in the end, speaking to my husband, you know, we decided, okay, let's just go ahead with this and see what happens. And that's what happened. And it was perfect. It all worked out. Not only did this mother help him in every way, but Gabriele told me that she was very attentive to his needs. And actually, Gabriele's friend warned his mother, because at one point Gabriele had to go to the bathroom, and to go to the bathroom, he had to walk up a step. And Gabriele's friend said, remember, Mom, that Gabriele needs to be helped. He needs to be helped up the stairs to go to the bathroom. So Gabriele's friend made his mom more aware of the issue, and it was wonderful. It's important to seek autonomy, not just the autonomy and the independence of the child in question, but it's something that needs to be extended to the people that take care of these kids that are around them. Only by helping each other and will these children be able to prosper. I don't think we can think that the child is equal to an illness. A child is a child, that they have difficulties that are related to the illness in question. But considering the child's strengths and weaknesses, we can help the child to manage his condition. I'd like to add something else with I think is really important. In this whole process, we were never alone. Obviously, we turned to the center, and it was of huge help to us. It's always better to work in synergy. It's always better to look at our situation from different vantage points. I think it's really great when you're able to speak to other parents, because other parents can give you really interesting input and suggestions. And this really can allow you as a parent to share your condition, your situation, to shed light on your concerns, and you will feel supported. So it's really important to have a counseling center to refer back to. And the meetings that we had there with other parents were extremely useful. So I'd give the floor back to you, Doctor.
Ringraziamo per aver condiviso.
Thousand thanks, and we thank you for sharing with us your own story, your own experience, a very valuable one indeed, which allows us to start from the difficulties, the obstacles or hurdles a family is confronted with once they receive a DMD diagnosis or Becker diagnosis. But most of all, as we were saying earlier on, in finding the psychosocial resources that they may activate. Now, let me just share the screen of my own presentation. Once again, thank you. As I said, because in your own experience and narration, you were already touching upon the most important or key points that we had in mind dealing with today with respect to what has got to do with the early infancy. And as you did, we would like to start from one of the hardest moments to deal with for a family, which is the dealing and coping with the DMD, BMD diagnosis once they get it. Now, only too often, your experience and stories come after long moments of doubting and uncertainties, having to try and find answers to the difficulties of your child. And this is highly destabilizing for the entire family. And you may even be prey of anguish, anxiety, depression. And in most cases, we tend to witness two different scenarios. On the one side, we may see a relationship with the condition whereby you don't talk, you do not cope with this situation, you deny the existence of the condition and of the diagnosis. And this is in part to protect yourself, but also the child. And on the other side, another different situation may come about. That is, the condition will be the very core of the family universe. Now, quite obviously, both situations do not allow the family to find a stable situation, a situation of stability. Both of them may be an obstacle in the process of building up the independence of the child, the autonomy of the child. A first element, which is sort of an antidote, is what allows the family to overcome this huge difficulty, or allowing the child to take off and start his own journey towards autonomy. The key word is awareness. And as Carmen and Marco were clearly showing by narrating their own and sharing with us their own experience, working on awareness is of paramount importance. It's a key thing. Rather difficult, very difficult. It's time consuming. It is also requiring a lot of patience. But how can we work on awareness? This is not something that you get sort of magically. Well, we may mention a few steps, useful steps, which make it more concrete, that allow us to switch from theory to practice. So in the first place, we have to break the protective circuit or cycle. We have to face the pain of loss. It is important for the parents at the stage of the diagnosis to ask for help, to get some psychological support. which is what will help them step into the pain of loss. And this is what allows each parent, which was idealized, imagined, so as to make room for the real child, the real earthly child. The second step could be the one of working from the shifting from the denial of the condition to the competence of that condition or pathology. In difficult situations, silence is very, very seldom a comfort. We have to talk about the condition with your own children, because this may allow you to share the emotions having to do, whether negative or positive, they may be shared. It's important for the children to know that even if this is something which is highly worrying the parents and worrisome for the entire family, it is possible to talk and to communicate their own feelings and emotions with respect to the condition. And parents will learn how to ask questions. And in the end, this is what will make them more aware in the first place. So their children, adolescent children, may be confronting themselves with their own friends and peers and be more aware about the assistance they may get and the support they may get. Another aspect which is also important is never to withdraw in your own pain, in your own situations. Parents usually, especially at the time of the diagnosis, tend to experience a misunderstanding, the idea of not being understood, the idea of not having other people understand what they're going through. Now, having a counseling center where families and patients may help other people, other families to share their own experience, very similar experiences. And they could also help us feel less alone, less isolated. Another obstacle with respect to the process of independence of the child or of the family is the one of overcoming the mechanism of hyperprotection. Being here, I would like to consider your own experience about the schoolmate friend that was inviting your son at home to play with him. And I was trying to keep my son just with me. I wasn't trusting anyone else. I wouldn't allow my son to be with anyone else because I was the only one capable of protecting. These are really the typical words that are applicable to families. Now, let's see what hyperprotection is. Hyperprotection is coming in two different shapes. One shape could be the constant worry on the side of the parent as to the possibility that something negative may occur to the child. And in this first case, the child may be perceiving that the parent is anxious, is afraid, and he may be somewhat absorbing this anxiety, developing a perception of being highly vulnerable. Then the second shape could be the one of the desire of protecting the child from any possible frustration. In this case, the parent will tend to replace the child, replace the adolescent, the would-be adolescent, because they are afraid that the child or would-be adolescent is not going to be sustaining the weight of such a situation. But what are these two hyperprotective attitudes provoking into the child? Now, let's see that. On the side of the child, with respect to these two forms of hyperprotection, may be developing two different thoughts, such as the environment is dangerous. This is the reason why my parents are always very close to me. And also because alone I wouldn't be overcoming these dangers. Or in the case of the hyperprotection aiming at defending the child from frustration, this is the second thought of the child. My parents are always next to me and supporting me. Without them, I am fragile. I could never bring myself to overcoming problems. But here again, there is an antidote. There is a keyword which helps us overcome the problem and in the first place, working upon ourselves. This experience of hyperprotection, and the antidote in this case is trust. For a child, trust is a key ingredient in its own journey leading to growth and adulthood. The child needs to be trusted by his parents and needs his parent to trust his own abilities and skills. It is important for the child to be free to explore, to move about, take initiatives, and also test his own limits and ask for help whenever needed, knowing that there will always be the protection of the parents that are there ready to help him. The glance of the parents is very silent because it is silently telling him that you are allowing him to choose when to go on and move about alone and when to ask for help. Because supporting this process leading to autonomy does not mean, as a matter of fact, that the child does everything by himself, but allowing the child to decide when to ask for help and when instead do things by himself. So he has to test himself and his own skills and abilities, in other words. Now, going back to support, let's now talk a little bit about the counseling center support with respect to the process of building up some independence and autonomy. The counseling center, CAD in Lombardy, is accompanying the family in the different stages of the life cycle, not only during infancy. And the CAD is suggesting different modalities and different strategies during infancy, but also during other stages of life, and how to work, how to favor the acquisition of independence and autonomy, providing 360-degree information as to the condition, as to physiotherapy, as to frustrations, so everything, and supporting the family when they receive the diagnosis and whenever they address themselves to the counseling center and whenever they have to deal and cope with the very fact that they have to communicate the condition or the diagnosis to the child himself and to maybe the sibling. Then the school. The school is the other actor which is present during the growth of the child. So family and the school have to be carrying out a coordinated synergistic activity and action. They have to allow for moments of encounter and meeting with the family, trying to promote that closeness, that sense of proximity and understanding through the counseling centers and listening centers, together with the psychosocial support during the trial. I would like to conclude this first part, which has got to do with the gaining of autonomy during childhood, by sharing with you my own reflections. Is it possible to be autonomous and independent, allowing other people to provide us with support? The support may be coming from the counseling center. Now, the answer to this question may see how important it is to make a distinction between autonomy and self-sufficiency. Both words refer to different experiences and contexts, and they should never be mistaken. With self-sufficiency, we are referring to the idea of being sufficient to our own needs, not needing any other support apart from what we can provide ourselves with. Whilst with autonomy and independence, we are referring to the idea of governing our own self, being the makers of our own life project. And this is what leads us to the idea that in order to be independent, you have to do things by yourself, and that depending on other people is a sign of weakness, of vulnerability, and being dependent. But in the very moment when a family finds itself dealing with such a difficult moment, such a complex moment, such as the moment when they receive the diagnosis, I believe that it is more than normal to feel unprepared and vulnerable. So this is what allows us to understand and to learn that asking for help does not mean that there is a lack of independence, autonomy, or being weak or fragile. It is rather the opposite. It is the moment when you are facing your own needs, the need to accept our limits, and to acknowledge the role and recognize the role and the importance that other people have in this journey leading to personal growth. Asking for help reminds us that we are not self-sufficient. We are not an island, and we are not an isle in ourselves, and that we are not isolated. So there are so many cross-sectional paths that we come across and in the course of time. And having said this, thank you for your attention, and I would like to pass the floor to Federica Corbetta, and she will be helping us or shifting us towards another step of the cycle.
Good morning, I'm a psychologist and psychotherapist. My name is Federica Corbetta, and I'd like to talk to you about the phase of adolescence and what that entails. In adolescence, there are certain needs that characterize this phase of life. It's the transition from childhood to adult life. Usually it happens between 13 and 17 years old, and every individual has to meet certain needs, integration of the personal identity, answering the question, who am I? Sexual experiences, and it also involves separating from one's parents and one's relationship with one's parents. And lastly, to process problems and issues that remained unresolved. It is said that adolescence is an excellent opportunity to make this transition. As regards identity, it often happens that adolescents identify with a single thing. So school, sports, physical look, or looks in general. So the risk is that in DMD, they might focus only on their physical condition, and they might think that they are what they have. Professionals should provide a linear explanation and say, I am what I have, but we must work against this. So what to do? Well, the best thing to do would be to show an interest in the person in front of us. So by asking questions like, what do you know how to do? What do you like about yourself? What do you like in general? What can't you stand in your friends and in your family? All these questions help us to understand the person before us, but they help the person about their think about their identity, who they want to become, what their values are, their wishes, and their tastes, really, so that in the end they do not identify only with what they have, the illness that they have. Reference adults, well, they're extremely important, of course, as they are in all phases. They are faced with the extremely difficult task of balancing out their role as supporters and fostering the adolescent's autonomy. I've chosen this picture to illustrate that this passage, this transition is natural, although painful, and we are likely to feel very strong emotions, as happens with many parents who experience a lot of conflict with their adolescents. So what are emotions? Emotions are a set of organic reactions that an individual experiences when they respond to certain external stimuli, and that allow the individual to adapt to a given situation. There are some keywords that are very important here. Reactions. Reactions mean spontaneous and autonomous movements. They are organic reactions. They are expressed through movements of our body. This means that they are universal and individual in nature. And especially these reactions help the individual adapt. So we mustn't control or manipulate them. I'm saying this because often persons don't want to cause pain to the adolescent in question, and so they try to deny their negative emotions. So a question often posed by parents is, my son is always angry. What can I do to make sure he doesn't feel angry? Or he's sad. What can I do to prevent him from being sad? The answer to these questions is this is not possible at all. What is possible is to modulate the intensity of these emotions. So the difference doesn't lie in helping the boy not to feel anger, but to express it, to channel it. So this doesn't only apply to adolescents, but also all the adults, the parents that are there to support the adolescent. The parent model in this time of life is a model that adolescents tend to walk away from because then remember that there is the need to separate from parents in this phase of life. So kids look for alternative models. As the picture shows, the peer group is definitely the model that most adolescents look to. They look to the way their peers dress, the kind of music they listen to, religious beliefs. Obviously, all of these are often in conflict with the parents' models. Sometimes models are assessed as negative. And this is something that needs to be borne in mind because a negative model should not be considered negative because we're biased, but it should be deemed to be negative only if it is detrimental to the adolescent. And in this case, rather than fighting against the alternative models, and rather than trying to go back to an original model, the best solution would be to further enlarge the possibilities and give as many alternative models as possible. So the adolescent is encouraged to develop their own resources. So what does a psychologist do? Well, the psychologist is responsible for trying to build a relationship based on mutual trust and collaboration. It's not possible to work without this basis, without these foundations, because a psychologist, of course, can do only a bit. The individual knows their life. When one or more needs are not met, the psychologist helps to identify which need is creating malaise and what the problem is. How do we do that? Well, in many ways. But the first and most useful way to go is to try to identify the negative emotions, because often these emotions give us a lot of information about what the adolescents are not able to adapt to. So it's important to consider the individual level and the closest relationships of the individual and the social context, how all of that is interconnected. Thank you for your kind attention, and I'd like to finish with this quotation by Mick Jagger. You can't always get what you want, but if you try sometimes, you just might find you get what you need.
Good afternoon. Thanks to you, Doctor. I am Vittore Montigi, and I am an educator, a professional educator. I will share with you my experience, what I do with my own boys. Okay, this is a professional school dealing with some themes, which I will briefly present. What we usually deal with our boys are themes such as independence, autonomy, and the theme of change, of communication, and of the development of one's own personal network, support network, independence and autonomy. One first step is the one of starting from observation, collaboration, the collaboration between the educator and the boy. And then after that, we start understanding what autonomy, independence means. For each one of us, it comes with a totally different meaning. But we may say that one key aspect which brings this concept and shares it with other boys having the Duchenne diagnosis is the one of collaboration with other people, friends, other professional carers or figures. And this brings us to develop a concept of autonomy and independence, which does not mean being self-sufficient outside of the family core, but also even outside of one's own family and home. And this is instrumental to reach our own wellness and well-being. That's the goal we all share. But how to reach that, how to achieve that? We try and exploit technology, make it favorable to us. And the metaphor is the one of a window, because this is a window which represents technologies, and it's open towards what exists outside our homes, to try and understand how to plan, to organize our own daily activities, daily living activities, even in the context of friends, whether family or just simply friends. But there is one thing we have to be careful about, is the limit. In some case, limits may take up a negative meaning, but to us, this is of paramount importance. Let's consider our sibling. The more we know him and the more we understand what is the range of motion, what is the range of vital movements and the vital space, and how and where to perform a number of activities. Now, how do we do that in order to get to know each other? We try and set up laboratories that are not separated or severed from the daily living activities, but they rather try and exploit and make best use of its own passion and of the entire background of the boy, so as to set up a setting or a laboratory allowing him to make the best of what exists outside, thus achieving the best knowledge of our own body and of what can be done in the space that surrounds us, and to specify our needs and requirements, being capable of clarifying our own needs to ourselves and to other people. Then another tool, which is very much instrumental and positive, is the idea of playing activity, role plays. Many of you probably know the game known as Dungeons and Dragons. And that is a tool which allows us to be protected by a character. The character is also then the element which will allow us to dare do things and experiment in doing things. So this is also one of the main characteristics of the game, whereby there is the complementarity of participation, the spontaneity in participating in a given playful activity or gaming activity, which is what allows him to be more inclined to be analyzing the situation and himself in a more critical manner, not rather thinking that the goal has been attained. Another thing is that you never work on performance, because performance is what creates anxiety. And when looking at this factor, we take stock of a given pathway which leads to growth. Failure may be something positive. If you fail, that's a fundamental element or situation that will make us understand what did not work the way it should. So this is something that should be used as a lever, because this sets the bar at a higher level. And if we can do that, we may be in the end capable of doing more things. So while exploiting gaming activities and playful activities, we may dare do things from the relational point of view, even from the social context point of view. This allows us to bring into the play some emotions. As Dr. Colbeta was earlier on saying, the game and the playful activity is allowing us to experience different emotions, even being angry. And anger, in some cases, is sort of set aside and repressed. And as professionals, we have to allow our boys to vent that out, to let it out. Now, at the end of the playful or gaming activity, we have a final session, which is the debriefing, where we analyze what has happened. And we always do that from a third-person point of view. And this is helping us to try and look at things in a more analytical way. While playing, we also try and clarify what the needs and requirements are to manifest them. We bring them to a more practical level. We have to allow to set them into a context. We try to also make use of photography, which is another passion, because this is what allows them to look at the objectives and goals and bring them into a situation which is highly constructive. One very normal, playful activity is the one of manifesting one's own need, referring them to the person who's next to us, which is what allows us to train ourselves, because sometimes we think that this is an easy thing to do, but it's almost always given for granted, which is not, never to be given for granted. And this giving for granted some of these things is a highly limiting factor, because it is limiting our own independence, our own autonomy. And then this leads, all of the games and playful activity lead us to a new communication. And this is a network, because we are never alone. Sometimes we feel alone, we feel isolated, especially families feel the burden, the heavy burden, which is weighing hard on their shoulders. But this is just like a plant that needs to be watered, to be tended to. And the same applies to the network of professionals, colleagues, friends that support us, the psychologists, the psychiatrists, the educators. Well, all of us may be referring to them in case of need. The network is something that needs to be taken good care of, because it's important to know that we all work in order to attain well-being. And then I must also underline that that this can be done thanks also to social networks and to online gaming, especially for the youngest ones. And let me stress this, you have to always allow them to go through that experience, because that's something they need to learn. And this is what allows them to transform the network, turning it into a community with other people that we may relate with, because we share something in common. And the community is not just limited to the territory. It is not only territorial, it's allowing us to go past the territory. And this is also allowing to feel boredom, to feel isolation, social seclusion. And sometimes we feel the possibility that any such tricks or tools or social tools allow us to overcome this sense of isolation. Why is this fundamental? The communication is fundamental because adolescence is a moment during which the body changes, during which relations change, during which needs change. And we have to be capable of supporting this kind of transformation so that the person brings them up to an aware level, to a conscious level, making them feel good and well. This is what allows them to do away with distress and discomfort. Now, obviously, here I have been listing only a few of the changing steps. The shift from the manual wheelchair to the electric wheelchair is something which adds for new independence, new autonomy. And thanks to this, we see the many steps that will allow us to go through different experiences that have their own weight. And each step leads to a further independence, to further needs, to new requirements. As Dr. Cornetta said, this is what may alight conflicts, which may be normal at all stages. There is a critical moment during adolescence, and during that critical moment, you need the support of professionals because they are the catalysts of different situations, and they bring together the different kinds of supports, social workers, psychologists, professional supporters. This is of paramount importance, and whatever we are doing is allowing them to reach their own well-being, their own independence. You can see the many colorful works that we could generate in the course of the pandemic, which was a way to manifest and to sort of show our own discomfort and distress because many things couldn't be done anymore. And thanks to the Counseling Center of Lombardy, we could allow for a series of steps allowing us to reproduce our moments, our feelings, our situations, and we could turn the discomfort into something nice, something that was sort of exercising and conjuring what was happening. Another aspect, which is very much symbolic, is the communication, because this is a very powerful tool, which is what allows us to make such a heavy burden light. We need to feel and experience new needs, and other people at the same time need to be increasing the sharpness of their own level of attention. And having said this, I would like to thank you, and I would like to pass the floor to my colleague. Thank you to Federica Corbetta and Dr. Vittorio Montisci for the interesting contribution having to do with the development of independence and autonomy at the time of adolescence, both from the psychological point of view and from the educational point of view. As we've heard, adolescence is a stage which is highly complex and rich. It entails a number of changes that are also connected to the presence of the condition. And they are also coming with the need of being acknowledged as an independent person. The need of the boys also change. The fact of taking up different reference models, such as their peers or other external figures, and no longer the family members. And quite obviously, that's a fundamental aspect. Especially, this is what supports the healthy moments of growth experienced by the boy. And the listening center, the Duchenne Listening Center, plays a fundamental role, as we've seen, not only at the time of infancy, but also at the time of adolescence, because it allows us to overcome the different tasks to be performed by the boy or by the family. It allows them to take care of communication, the inter-subject communication, family and disabled, or siblings and disabled, the support to the family, to the many changes. And that could be also done by the professionals working across the territory. And apart from the support at geographical and local level, there is also a listening center, which then allows us to face another step of this journey, that is adult age.
There are several elements that describe this phase, and these elements will be illustrated by Luca Anecchino, who's 33 years old with DMD. He lives in Rome, and he's very active participant in parent project activities. Today, he's going to tell us his experience of independence in adult life. He will bear witness to his experience and share with us his reflections. After him, there will be a part devoted to psychological effects. Thank you. First of all, I'd like to greet everyone. As was just said, I'm going to share with you my experience of adult life as a Duchenne patient. For some years now, I've attained the goal of living on my own. Right now, I live together with my personal assistant and his family, his wife and 2 children. We've created this cohabitation arrangement. And right now, therefore, I live independently, meaning that I do not live with my parents, who I used to live with beforehand. I can tell you that this was an extremely important step in my life. And of course, it wasn't something that happened overnight. Obviously, there were several steps that needed to be taken beforehand, and this was made possible thanks to the coming together of certain issues and elements that combine nicely. First of all, I was able to find a trusted personal assistant whom I've known for many years. Thanks to my personal assistant, I was able to start thinking about this project, my plan to live away from my parents autonomously. At that time, about 4 years ago, I talked it over with my parents. We discussed the matter. And in the end, we went straight to the point. We made the necessary arrangements. For example, we had to look for a home that would be accessible to me. That would be arranged in such a way that would be accessible. And then, of course, we had to organize things with my personal assistant, who, once again, I say, was crucial and key to this whole plan, for the plan to work out. Because if you have this ambition, you absolutely need to find somebody who you can trust. There must be absolute trust on the part of the caregiver and on the part of the person being cared for. So if there's no trust between the 2 individuals, it's very difficult to make this sort of plan happen. So, thanks to this long acquaintance and to the trust we had in each other, in the end, we were able to go ahead with the plan, and we were able to make it happen. I think that the idea of achieving this goal is really crucial, very important in order to meet the needs of an adult with DMD. As regards my experience, I can tell you that the idea of living in independent life is among the main needs, and maybe it is the main need in an adult with muscular dystrophy. I think it's probably the most important need that needs to be met. Of course, it's not the only one, and at least I'm speaking out of my own personal experience, there are other needs that are connected with this main need for independence and almost total autonomy. The goal, of course, is to live a life that can be as fulfilling and as full as possible in spite of the obvious limitations due to the illness. So, to achieve this, there are other needs that have to be met, starting with adolescence. So personal fulfillment is one of them, which means that the person, the individual, should complete a cycle of studies. They could even maybe get a job, be part of the active workforce. Another need is to have friends and significant persons in your life. All of this, of course, contributes to making our life as full as possible. Having a social life is key. And maybe being able to partake in different activities that are part of everyday life. For example, the possibility of going out with friends, or the possibility of going out to a bar, or attending a course, or just engaging in any other activity that can enable us to be involved in a relationship with other people. This is crucial. I think that it's necessary to improve those projects of independent living that already exist and develop others. So locally, and I mean regionally here, all the way up, I think that these projects should be further developed and fostered. Because once an individual is able to find a reliable personal assistant to support them in these projects and in these plans for independent living, once that happens, then obviously we have to reckon with the financial side, because in addition to expenses determined by everyday living, the larger expense has to do with being able to pay a salary to your personal assistant or your caregiver. So that would be next to impossible without funding from outside sources, maybe regional funding, or without funding from ad hoc projects, it would be prohibitive. So I think the economic or financial aspect is one that must not be neglected in all of these projects that already exist, that are already out there, but that are not sufficient yet to guarantee that everyone may enjoy this possibility and meet this goal. So I think it would be important to start thinking about how we can improve these projects and how we can come up with even better ones in the future. Obviously, I think that there is a whole lot to do, yeah. But bearing in mind all of the components of the challenge here, I think that we can definitely largely improve on this idea of securing an independent life to adolescents and adults with DMD. I think it's our main goal. Luca, I'd like to thank you very kindly for your words. It was very valuable to listen to what you had to say, and we're now going to delve into the more psychological aspects related to this plan of living on your own. But your words were very enriching indeed, your whole witness. And let's now move on to the presentation concerning the psychological dimension related to living on one's own. I'd like to share my screen. Let's once again go back to the main theme of our round table and let's look at the psychological aspects.
Especially with respect to the experience of independence that may be experienced in adult life. As we have seen, and what we have discovered while listening to the presentations, having put the focus on infancy and adolescence, we now invite you to work on the theme of independence. And starting from the very moment we are born, we have been given license to exist as a person. It's as if inside ourselves there is an inborn desire to grow and to evolve, and age, growing up, represents the greatest expression of being capable of realizing one's own project of independent life. It allows us to feel powerful. We have the power and we are empowered to study, to work, to travel, to take part in a conference. In other words, I may choose the direction I want to take in the course of this journey, the journey of life and of living. And adult life is probably the sum of what we have been building in the course of time. That is a series of resources that then come useful during adult life to develop a project such as the one we have heard and that Luca shared. Now, what are the resources that Anna and that the family, together with the colleagues of the adolescence session, were sort of narrating and sharing with us? Trust, confidence, the ability to explore, which should be seen as resources that the individual develops ever since he's young. The idea of becoming self-independent to carry out a project which probably is different or can be different from what the family would have liked for us, such as getting degrees. But anyway, this is the foundation for a solid starting base, a sorting leading to coping with limits, frustrations. Luca, just a few moments ago, was mentioning a few of them with respect to the idea of the economic aspect, being capable of tolerating, of handling all this and coping with all this in the light of our own resources. And that is also to be coming to terms with the presence of our own condition. And we have seen together with Dr. Montisci and Dr. Corbetta how adolescence is the moment when we know that we are sort of establishing and putting the roots of allowing the young adolescent to grow older and emancipate himself and embark in his own project. This is applicable to the Duchenne and Becker dystrophy, and we know that all of these resources may coexist in a fluid manner, in a liquid way, allowing us to enjoy inner movements that lead us to become independent. The external dependence is sometimes different from the carer, the figure of the carer. Dependence, which is what aims at making that Duchenne person or Becker person become independent and autonomous. This is something that allows the full accomplishment of that life project. What is a life project? We may define it as the set of the objectives and goals of a person, goals and objectives that are very personal, which may rest upon our own needs, wishes, ambitions, and they are in the end supported by our own inner motivations to achieve them, but also by the presence of external resources that may be functional. That means that the life project is responding to a question. What is it that you wish for yourself? What is it that you want to accomplish in the course of your life? And one answer could very well be, I want to study. I want to become a graphic. I want to have my own profession or activity, independent activity. So this is the expression of part of the life project, which has got to do with the training or formation project, professional project. And whenever we talk about life project, then we touch upon two different themes that we have been coming across many times over in the course of this roundtable. One is the meaning and the value of the roundtable, independence, autonomy. Well, these two terms only too often are interchangeable. And technically, they are very close one to the other. They sort of overlap. We may define independence as the possibility of feeling independent within. That means from the inner point of view, whilst autonomy is the possibility to act and to become fully independent. Now, in the course of our own project of evolution, the fact of tracing back the two elements is of paramount importance, because that stands as the very, very starting point of a project of life, an independent and autonomous life. Now, we've seen that in the course of infancy and then of adolescence, there may be some difficulties met by both the child and the boy and the family, because they also represent some steps experienced by the family and the child. But there may also be some hurdles, some stops and blocks, which one may be met with. Amongst them, there are symbiotic or independence moments where the relationship between the young adult, and his own family is very symbiotic, very much connected, strictly connected. And this is what feeds and allows the boy and the family to remain in a climate of dependence, whilst living on one's own is perceived as a severing of this connection. So this is a matter of choices that sometimes are experiences as with some guilt. There is a fear of feeling lonely, of being abandoned and not being capable of leading forward in an independent way this project. Or sometimes the idea of abandoning one's own family, a family with which a very strong connection and dependency was developed. And all this may lead to a situation where the young and the adult will sort of adjust. They sort of accept the idea of having one's own independence in the broadest sense of the word. Sometimes they rebel against that, they react. Or sometimes the boy or the family somehow start looking at or criticizing the work conducted by the operator and the assistant. Sometimes this is sort of a block and a stop to the development of the project. This develops a sense of negativeness, something which is a climate which will not allow them to understand how much that affects communication, cooperation, the communication and cooperation between the boy and the family. And only too often they turn into conflicts or difficult obstacles. With this respect, there may be some difficulties in adjust from the psychological point of view to adjust to the physical changes. And this is typical of what happens in between adolescence and adulthood. And sometimes already during infancy and childhood, if there is no good communication between the child and the parents or the network supporting them with respect to the condition, then later on, the more we progress with age and the more we become adult, it is going to be difficult to cope with the many changes, even from the physical point of view. All this may lead to the onset of defensive mechanism, protection mechanism. From the psychological point of view, these mechanisms lead to the denial of the situation, the avoidance of facing it, or the fact that the family believes or starts believing that they can't be helped by anyone, by nobody, that nobody can help them. So this may lead them to develop a mechanism of anxiety. So this difficulty to adjust whenever this happens, especially in the early adult age, well, this is what may lead to true psychological disorders, mood swings, withdrawal within oneself, not only suffered by the boy or by the young adult, but also by the family and other family members. Another aspect which has got to do with the psychological adjustment has got to do with the difficulties to cope with the many changes having to do with the life cycle of the family. For example, going out, or the fact that one of the siblings is leaving the family because he or she is getting married. And this is what alters the delicate system of equilibrium that the family has reached, even in the previous stages of life. This is what becomes or makes it so difficult to handle all this and to cope with this. We've also talked about the testimony of Luca, and we've heard how important it is to allow oneself to have an independent life, because this needs and requires some personal work, because this means that we start looking for what are our own true needs. What do we need to lead forward our own life project? Some of them may be physical needs, such as eating, sexual needs, existential needs, the fact of having a personal assistant, for example, that is in charge of the management of the daily life of that adult. Then the psychological needs, which have got to do with the cognitive and emotional sphere that surrounds the person, the relational aspect, the family, the emotional aspects, the social needs, which have got to do with the sense of belonging to a group, playful, recreational, sporting activities, and last but not least, since we are here dealing with the adult life, the training needs, for example, the choice of a university teaching. All this is what will shape the identity of the adult, because it's the adult in the end who will choose on the basis of his own needs. So being adult doesn't mean that you don't have any needs. Adult age sometimes is leading to the fact that we need to focus on our needs. We have to recognize and acknowledge the fact that being adult does not mean not needing anyone's help. Even in the adult life, a Duchenne adult or a Becker adult has to learn that being an adult means that you have to learn to ask, and to ask in the appropriate way. Then let's look at the tools that allow us to project and plan our adult life. The tools are the ones that are known as resources from the psychological point of view. That is to say, the tools, the inner tools, the personal tools, the external tools that are available to us in order to lead forward the project. For example, this entails the acknowledgement of the value of our own self-value, of our thoughts that leads to good choices, the fact of achieving the goals, even while being supported by the network, the social network, the family network, the possibility of choosing, redefining, depending on the situations, on the needs, the fact of dealing with anxiety, frustrations, which sometimes are due to the many hurdles we are met with, and the ability that we have to resist to the challenges that life presents to us, learning from them, and the possibility of defining our own independent life depending on our own motivations and needs, how to structure the time frame where our inner time is running parallel to the needs of our body. This is something very important because the body is not an eunuch. It is sort of a company, something that is supporting our own inner needs and internal needs. So this is to accompany also the physical needs, the bodily needs. And once again, the ability of sharing one's own needs and interests means that we have to be capable of providing and giving instructions from the communication point of view, the ability of facing life one step after the other, and the fact of being capable of feeling ourselves and seeing ourselves as part of the community, as we just heard. Now, what are the external resources? The external resources may be represented by all of the resources existing outside in the external world, such as the family, the territorial resources, the school, the working place, the friendships, the social assistants, the social operators, the association of parents and diseased people. All of these resources may be consolidated, renewed, depending on the project of life that one decides to pursue, and also on the basis of the different contingencies of our life. This conference this year is focusing and revolving around time. Time stands as a key element, which allows us to decide what are the resources we want to exploit. We may focus on the present time, and then we may ask ourselves, what do we need so as to plan my future independent life? What may I need in future times so as to lead forward and lead to the next step my plan and project? What is it that I may make and use in the best of the ways? So this turns into creativity as the expression and the ability to create also by being supported by the network, and to finally achieve our own life project, make it come true. There are different ways of becoming independent because each one of us has its own personal autonomy concept and independence concept, which is what then signifies and allows for the freedom of expression of the individual himself. So here are some of the aspects of the project of independent life, which have got to do with the learning progress, the learning stage, the university learning, the participation to group, being member of a group, one's own holidays, the sense of belonging to dedicated groups, such as the Boys of a Parent Project. Now, the choice of having one's own personal assistant who is in charge, whether in part or completely, of all of our adult life aspects, the active and aware participation in taking part to the decisions affecting our own life and health, or bureaucratic life or decision-making aspects. So here are some of the ways to plan one's own adult independent life. And this is telling us that the project of independent life is flexible, adjustable, and customized depending on the needs of the person. That means that it does not entail necessarily the fact that the boy will leave the nest and go and live by himself and in an independent way. So this is sometimes envisaging a symbiotic experience. Sometimes we think of independent life projects and you necessarily start thinking that you have to leave your nest and go and live by yourself. Now, what is then the role of the psychological support provided by the Duchenne Counseling Center? We know that it is there, present, available ever since early childhood till adult life, because this is something that allows you to proceed in a manner whereby from your childhood, you may finally be in a situation of go and enjoy your independent life. That means that you have to make the best of the family. You have to start listening. You have to detect the necessary tools that allow you to understand your needs. That means that you may be helped by professional carers, informal carers, such as the family members. You may be in turn helping the building up of a network, thus expressing the needs in terms of care from the regional point of view. You may favor the sense of acknowledgement of your needs and motivations. You may then be accompanying the process of adjustment by attaching importance to the time variable at all times of your own journey, then stimulating the active participation into the community and the support of individual or group projects, supporting the communication with your siblings, brothers and sisters, favoring individual sharing and group sharing occasions, and allowing for operators to step into the play whenever necessary. The listening center support is something which is across the territory. It is implemented by means of family psychotherapy possibilities or pathways or personal psychotherapeutical support and support and psychotherapy for siblings, parenthood support and psychotherapy, and the supervision of both the family and the involved person. And this is how we come to the end of all of these aspects. Let me conclude. And I am now coming to the end of this round table, which is the journey which leads to independent life and autonomy by going through and across different steps, which may be the ones of early childhood, adulthood, adolescence, and then the adult life. And I would like to thank all of the participants. Once again, Marco and Carmine. I would also like to thank Dr. Corbetta and Dr. Montisci and Luca, who was here with me in this phase of its own adult life. And now we would like to allow for possible questions and answers. And I myself, together with the other speakers, make ourselves available to answering your questions.
I see that in the meantime, we've already received a number of questions. We are running out of time. So my colleague and I will answer on the chat, even in the course of the next sessions. Should there be other questions, we will publish information in order to keep our discussion going on this topic. So we'd like to thank you for being with us, and we turn the floor back to the spaceship. Thank you, Giada and Anna. Thank you. Once again, we're connected from space for the last scientific session of this extremely intense
di correzione genica a moderare,
in which we will be speaking about gene correction. Ezio Magnano will be co-chairing this session along with myself. He's a representative of the board in Sicily. He's connected from home. And before giving him the floor, I would like to remind everyone that if they wish to have interpretation into Italian, click on the icon in your bar at the bottom of the screen and select the language of your preference to be able to follow with interpretation. I'd like to remind you also of the fact that at 6 p.m. there will be a side event, very interesting, on sexuality and affectivity. So without further ado, I'd like to give the floor to Ezio. Thank you, Ilaria. Good afternoon, everyone. In this fifth session, speakers will illustrate the research and they will tell us how to correct and restore dystrophin, which is shorter but functional nonetheless. We will speak about the first drug for DMD to have been approved in Europe. Before I give the floor to our speakers, I'd like to share some material produced by our association and the video made available. The purpose is to get everyone to understand what a trial is all about and how families can get involved. All this material can be easily downloaded from our site. An important time of our path was related to our participation in an initial trial, specifically the trial that was performed by GlaxoSmith and then continued. We participated in that trial. I said we because we as a family and not just the individual patient was involved. That was the first trial using this molecule, and the whole DMD Duchenne community had great expectations. These expectations, unfortunately, were not met, and they simply reminded us that a trial is mainly involving the laboratory, and it's just a step along the long process. A trial is a trial, it is not a cure. The trial I'm mentioning was actually discontinued prior to its natural end. But it's important to say that it was really a point of departure for continuation of studies and trials in this area, which led to the current scenario. This session is one in which we're going to hear about progress made by science with exon skipping. We hope to have learned from previous mistakes in previous trials. Let us truly hope that what on paper might seem like a failure can actually be a progression of a technique that is not a failure, but that needs to be fine-tuned because it is so highly complex. Before I give the floor to our speakers, however, I would like to give the floor to Ilaria Zito, who will explain the molecular foundations of gene correction that we're going to discuss in this session. Thank you, Ezio. Thank you for your testimony. It's always very valuable to hear from parents. It's an added value, and these witnesses should guide us. They should be sort of the reverse scientific information that goes from the patient to the researchers. Let me just introduce this session briefly and give you the context and the molecular foundations. We're here to talk about gene correction. In this slide, you will see an introduction which shows us the flow of information that from DNA flows to the protein. So on the left-hand side, you see the nucleus where you have our DNA, all of our DNA. And every gene in the DNA transcribes, it forms this messenger RNA, which matures, goes into the cytoplasm, and there the message of messenger RNA is read by an apparatus that translates it into a protein. The strategies for gene correction and mechanisms can happen at different times. Yesterday, we looked at an initial strategy, and that is gene editing. That Professor Charles Servisbach talked to us about. Today we're going to go into other two strategies. The first acts at the level of the maturation of messenger RNA maturation, so exon skipping, and the other acts with it when the message is translated into a protein and it corrects. It's a strategy that corrects mutations in one sense. Both these strategies are mutation specific, so that they can be used only in a certain number of patients who present with certain mutations. And both strategies are therapies that involve repeated administration over time. As to exon skipping, we have messenger RNA that undergoes maturation. What does that mean? Well, in this molecule, you have building blocks, which we have all learned about. Exons. There's 79 in the case of dystrophy. And these exons are separated from each other and have to come back together in the mature messenger. Here you will see part of this messenger. You see exons from 50 to 57, and you can see how each one of these exons fits into the previous and the following one in a specific way. Now, obviously, this is highly simplified, but there are certain mutations of patients with Duchenne that have deletions if in the absence of one or more exons. So when the exons are absent, the exons that come before and after no longer fit with each other, 51 and 53, for example. So that means that the reading of that message is interrupted at that point. The protein that's produced is degraded because it's chopped off, and so there's no protein. The exon skipping technique seeks to recover, reintroduce reading all the way up to the end of the message. It uses certain molecules that are capable of binding in certain regions and promote the skipping of another exon, so that the two exons that are next to each other, in this case 50 and 53, can fit together, and so that we can come to the end of the message and obtain a protein that will be shorter, but that will be partly functional. We have many molecules that are being looked at and studied with this strategy that seek to skip 3 exons in particular, because if skipped, these 3 exons can correct the mutation in quite a nice number of patients. Specifically, 4 of these molecules to date have been approved only in the US, not in Europe anyway. As a drug, I mean, they've been approved as a drug. 2 for the skipping of exon 53, 1 for 51, and 1 for the skipping of exon 45. Studies are continuing, and we really do hope that as they progress, it may be possible to secure approval of these drugs in Europe and therefore in Italy. I also wanted to say that there is progress and it is visible because the molecules that are being studied today are increasingly innovative. They're defined as new generation molecules because they make the system more efficient. They target it, or rather they channel it more specifically and directly towards the muscle. And they allow for administrations that are more distant over time, not so close together. The other strategy corrects nonsense mutations, which we find in over 10% of patients suffering from DMD. We're talking about the cytoplasm here. We have the mature messenger molecule, which is read by this apparatus.
Il messaggero e genera a mano a
which
mano
runs across the messenger and generates the protein, which you see here, which is progressively formed until it comes to the release of the protein naturally. When we have a nonsense mutation, what happens is that the mutation introduces a stop signal before it is due. So it's a premature stop signal. So this means that when the machinery, the apparatus runs across a messenger, it stops and the protein is degraded. The strategy to correct these mutations involves a drug called Ataluren, which can bind to stop signals and which allows the system to bypass the stop and continue the reading up until the natural stop signal of the protein. So in this case, we also have the advantage of having a full-length protein. Ataluren is also known as Translarna with its commercial name. It was the first drug to be approved in Europe and in Italy, of course. And it will be discussed by Professor Mercury at the end of the session. I have concluded my presentation, and before giving the floor back to Ezio to introduce our speakers, I'd like to remind all panelists or speakers to please speak slowly to facilitate the work of our wonderful interpreters who are working very, very hard. And I'd like to remind all those who are listening to please start asking your questions in the Q&A that you see low on in the bar on the screen. Ezio, you have the floor. Thank you, Ilaria. Let's get into the heart of the matter. I'd like to please ask the speakers to stick to the time allotted to them. And it's with great pleasure that I introduce Lorna Hill from Global Medical and John Tinsley from Sarepta Therapeutics. And they will both speak to us about their development programs with their exon skipping platforms.
Thank you very much, and good afternoon, everyone. My name
le sperimentazioni in varie fasi di sviluppo per lo skipping di 3 esoni differenti. Prego, dottore.
Yes, go right ahead.
Okay, thank you. So welcome, and I'd like to say thank you very much to Parent Project Italy. It's a great honor to be here with you today, even if we are together virtually. My colleague John Tinsley and myself are pleased to give you an update on our PMO and PPMO exon skipping therapies that we are developing. It's our mission, which each work by never forgetting the importance of what we do armed with the most advanced science.
Lorna, I'm sorry.
Yes?
Excuse me. We see the wrong monitor. So we see the relator view. So please change the display setting. Thank you.
Yes, of course, of course. Is that better?
Yeah, thank you.
Thank you very much for letting me know. So just to come back to Sarepta's mission, so really we are sensitive to time and in a race to rescue lives otherwise stolen by rare disease. I would just like to take a moment to show you our forward-looking statements on our webcast and a reminder that our therapies are not authorised in Europe. Today, we will be speaking about our goals for the future, and there is risk and uncertainty associated with speaking about the future. I will briefly describe our pipeline. So at Sarepta, we continue to advance our broader 40+ programme research and development pipeline with a special focus in Duchenne across exon skipping treatments, gene therapy, and gene editing. And we continue to explore new and improved delivery mechanisms. We also explore therapies for additional neuromuscular conditions such as limb-girdle muscular dystrophy. To drive ongoing success and overcome challenges in developing new medicines, it really does take a village. We continue to further strengthen our unique first-in-class team of genetic medicine professionals across academia, research and industry. And we're proud to say this also includes our Sarepta and Roche partnership, working together to meet the needs of the Duchenne community. And together we will reach more Duchenne patients faster than we could on our own. So now I will focus on our PMO exon skipping and our clinical trials. And firstly, I would like to take this opportunity to thank the study participants and their families, whose relentless dedication, despite the prolonged impact of the pandemic, really make our clinical development programme possible. So we've already heard about the technology for exon skipping. This slide shows our exon skipping here. We know in Duchenne that the dystrophin gene is not able to make enough dystrophin critical for muscle function. And you can see at the bottom of this slide, the graphic represents a small piece of the dystrophin with exons 39 to 51 showing of the 79 exons. And this is really like a linear jigsaw with different shaped exons, the shape complementary to adjacent exons. And a mutation in the dystrophin gene, such as deletion 43 missing here, could disrupt what is called the reading frame, resulting in no dystrophin being made. And this is illustrated by the car you can see at the bottom, as if on a road, unable to drive over the missing or deleted exon. So the goal of exon skipping is to restore this reading frame by skipping over an exon near the deletion. In this example, exon 44 is skipped, and skipping allows the car to continue driving past the region where the deletion occurred. So this slide here shows our 3 PMO exon skipping programs designed to address up to 30% of individuals with Duchenne, with deletions amenable to skipping of exons 51, 53, or 45. Each of these trials is designed to evaluate the safety, tolerability, and efficacy of the PMOs targeting to skip the exon deletions. Further information can be found on clinicaltrials.gov, as you can see at the bottom left-hand side of the slide. So firstly, we'll talk about MISSION, which is a randomized study of a high dose of exon skipping 51 in comparison with the approved dose of 30 milligrams. And this is approved in the USA currently and in Israel currently. We have completed the open label dose escalation part. Trial eligibility includes boys aged from 4 to 13 years who are ambulant and have a deletion amenable to exon 51 skipping. And we plan to enroll 152 patients across 40 or more sites globally, including Italy. and the study is open and recruiting. SKIP-NMD was a randomized placebo-controlled dose titration study of PMO skipping, exon skipping 53 with golodirsen in patients with a deletion amenable to exon 53 skipping. The ESSENCE study is a currently open study, a double-blind placebo-controlled study of 2 PMOs targeting exon 53 and 45 skipping in patients age 6 to 13 years inclusive with relevant deletions. We're pleased to report that this trial is recruiting well in multiple sites globally, including several sites in Europe, including Italy. And we would like to show you just an overview of where we are with our clinical development program for our 3 PMOs. This slide shows an overview of our development plan and real-world evidence studies for eteplirsen, with the phase 1 to 3 clinical studies which are completed to purple and on blue, which includes the mission study. The mechanism of action, i.e. exon skipping, and a resultant significant increase in dystrophin production has been confirmed in several clinical trials. Clinical trial findings suggest eteplirsen treatment may prolong ambulation and preserve pulmonary function. Significant risks with eteplirsen identified to date, but please note this is still in Europe. Here is an overview of our golodirsen development program, which adds to our growing body of evidence in PMO development. Study 4053-101 provides evidence in a declining Duchenne population for the biological activity, potential functional benefits, and long-term safety of golodirsen up to 189 weeks. And my final slide here shows our development program for PMO exon skipping with casimersen and the open and recruiting ESSENCE study. So I'm going to stop here now and thank you for your attention, and I will hand over to my colleague John Tinsley to present an overview of our PPMO programme.
Thanks, Lorna. So now moving to our PPMO. So good afternoon, I'm John Tinsley. I'm the Executive Director of Clinical Development at Sarepta. I'm pleased to share an update on Sarepta's next generation peptide conjugated PMO named SRP-5051 that is designed to be an enhanced version of our PMO technology for Duchenne patients who are amenable to exon 51 skipping. The possible PMO limitation is that it's neutrally charged and only gets into the cells passively, potentially limiting the amount of drug into muscle. This presents an opportunity to build upon our PMO approach and develop what are called peptide conjugated PMOs, otherwise known as PPMO. This extra P is for peptide. The PPMO uses a positively charged peptide attached to the PMO to help actively drag more of the drug into the muscle and the heart. And that's been clearly demonstrated in animal models. More of the PPMO gets into the muscle and the heart, resulting in more exon skipping and more dystrophin. Now, as we study SRP-5051 PPMO in human trials, we're gaining insights on safety and dosing with the goal of producing high levels of dystrophin with dosing for patients once every 4 weeks. Next slide. So SRP-5051 is designed to skip exon 51. We've completed the first in-human trials that you can see here on the left panel. It was a phase 1 study looking at safety, tolerability, and drug exposure of a single dose of SRP-5051. Importantly, participants who were in this study had the option to enroll into an open label extension study, which includes increasing doses as higher doses of SRP-5051 are shown to be safe. Now in the center panel, we initiated dosing in a multi-ascending dose study, 5051-201, which is now called Momentum. Momentum is a multi-arm ascending dose study of SRP-5051 infused every 4 weeks to initially assess safety and then followed by dystrophin protein level in skeletal muscle tissue. The study enrolled both ambulant and non-ambulant patients. They were aged between 7 years and 21 years of age, and there were sites within the US, Canada, and the EU. Now on the right-hand panel, last year we announced positive results from SRP 5051-201, Part A, and in the 30 mg/kg cohort, when we compared that to previous data from eteplirsen, we saw an 18-fold increase in exon skipping, an 8-fold greater level of dystrophin production, all of this in half the time. We were able to demonstrate a 6.5% mean of dystrophin protein production after only 12 weeks of dosing. But of note, we also noticed a dose-dependent hypomagnesemia. So this is increasing levels reducing levels of magnesium in the serum. However, after a lot of investigation, we believe that this is both monitorable and manageable by simple prophylactic magnesium supplements. We then gained FDA's concurrence on the commencement of Part B of Momentum, which will serve as a pivotal trial for SRP 5051. We can move on to the next slide. So a brief summary of Part B. So the status of Part B is recruiting. As I say, there's two areas where we're looking to recruit. So we're looking for the previously treated, and these are called PT, so previously treated patient who have been on SRP 5051 before. So these are patients who either were in the 5051-102 study, so what was the time an extension study, or the 5051-201 Part A. So these study endpoints are all around safety, tolerability, and pharmacokinetics of the drugs. In this group, because they've already had biopsies, no biopsies are required in this group. Now the other group are what we're calling the treatment naive group of 5051. So here we're looking for around 30 new patients, so naive to 5051 treatment. And here the primary endpoint is a change in dystrophin protein. We're looking at a difference between the baseline and treatment after 28 weeks. And the secondary endpoints are safety and tolerability, PK, and other measures of dystrophin. And the main inclusion criteria for this group is again, we're looking at ages between 7 and 21, either ambulant or non-ambulant. They have to agree for the 2 biopsies on a stable dose of corticosteroids for at least 12 weeks, or have not received corticosteroids for at least 12 weeks, and stable lung function. So in Part B of the study, the patients will receive safety monitoring for hypomagnesemia, but also will continue the safety monitoring for renal function, as this is a known risk for these kind of molecules, for antisense molecules. And I say for further details, please speak to your treating physician or your local patient organizations around this study. So we can move on to the final slide, please. So here, a huge thank you to the families and the boys who participate in our studies. We know that participating in a clinical trial is not easy, but be assured we are working hard to try and improve your experience based on the feedback we get from you, from the patient organizations, and the Duchenne Community Advisory Boards. Your dedication will help to improve the understanding of this disease and will hopefully inform progress to more meaningful treatments. And on that, I shall finish our presentation. Thank you very much.
Grazie a voi, ringraziamo per I vostri preziosi interventi la dottoressa Lorna Ind.
Thanks to Dr. Lorna Eve and Dr. Tinsley, and I would like to remind you that at 6 p.m. there is a parallel session on fertility and sexuality. Now, second contribution comes from the NS Pharma, having to do with the Viltepso or Viltolerance molecule approved in the US, which has been experimented in other countries. We shall hear Robert Krazier, Vice President of NS Pharma and also medical advisor.
Hello, good afternoon, everyone. Thank you very much for inviting us to come speak with you today. I hope I'm speaking slowly enough for the translator. I am representing NS Pharma, and I am here to talk to you today about Viltepso, or Viltolarsen, and exon 53 skipping therapy. As Lorna mentioned, we are also not approved for use in Europe, and my presentation may contain then forward-looking statements. Just briefly about our company. I am from NS Pharma, and our offices are located in a suburb of New York City in the United States. And our parent company is Nippon Shinyaku, and they are based in Kyoto, Japan. And they are a 100-year-old company, and NS Pharma operates as a small biotech company, so we are nimble and able to move rather quickly, but with the support of an established company. It's about Viltepso.
Mission, parte in Italia.
We received accelerated March of 2020, United States, in August of 2020. And accelerated approval is a regulatory mechanism that allows drugs to come to patients more quickly. As part of the accelerated approval, we must perform a randomized phase 3 placebo-controlled study, and this is the gold standard for clinical trials. And this trial is called RACER 53. And although we are not approved for use in Europe or in Italy, we do have a site for this study in Rome. The data that I'll be showing you today is from a phase 2 study in North America, and I'll be showing you those results in a few moments. That study also had a long-term extension arm, and we presented those results, interim results, last year at World Muscle Society and Child Neurology Society. We also have another ongoing trial called Galactic, or Galactic 53, and that study also has a site in Rome, and that is being conducted in patients who are ambulatory as well as non-ambulatory. And both RACER 53 and Galactic 53 can be viewed on clinicaltrials.gov for more information. Exon skipping was covered very nicely at the beginning of our session and also by Lorna, so I won't repeat it. I will only say that our drug skips exon 53. Some of the more common mutations are shown on this list below, and you'll notice that many of them, or all of them, end in 52. So 43 to 52, 45, 47, 48, 49, 50, and 52 alone are some of the more common deletions that Viltepso may be amenable to. So as mentioned, Viltepso is an exon 53 skipping therapy that for patients who have an amenable deletion. And it's gained approval under the accelerated approval process. And we are currently undergoing a phase 3 trial for confirmation of those results. The dosing is 80 milligrams per kilogram of body weight. It's a weekly infusion that's given over 60 minutes. I think I will skip this slide only to say that common side effects include upper respiratory tract infection, injection site reaction, cough, and fever. Okay, now for the results. I'm not going to go into all the details on this slide. If there are questions about them, I'd be happy to answer questions about this study design, but there were two doses, a high dose, 80 milligrams per kilogram per week, and a low dose of 40 milligrams per kilogram per week. And it was a 24-week study. Muscle biopsies were taken before a drug was given, and at the end of the study at week 24, and 8 patients were in each group of the 80 milligram and 40 milligram group. And boys were aged 4 to 9 years old. And it was a 24-week study. And then patients could enroll in an extension study for an additional 192 weeks. The primary outcome was dystrophin induction as measured by Western blot, also safety, tolerability, and pharmacokinetics. And then a number of different secondary outcomes that supported the Western blot data, including mRNA skipping, localization of the dystrophin protein using a technique called immunofluorescence staining, and dystrophin protein production by another technique called mass spectrometry. There were a number of clinical motor assessments, including time to stand, time to run walk, time to climb 4 stairs, North Star ambulatory assessment, 6-minute walk test, and quantitative muscle testing. And I'll be showing you some of these data in a moment. These are the data for which we received accelerated approval. These are the Western blot data. As I mentioned, muscle biopsies were taken before treatment and at the end of treatment. This is the before treatment value for the 80 milligram per kilogram dose, and that was 0.6%. And after 25 weeks, that number went up to nearly 6%. This difference was statistically significant, and all patients exhibited an increase in dystrophin levels from baseline. On the next slide, I'll show you some clinical outcomes data. So we're looking at time to run walk, time to stand, and 6-minute walk test. The Viltepso patients are in dark blue, and they were compared to a natural history group from the Synergy registry. And as we can see, measurements were taken at baseline, week 13, and week 25. And what we see with time to run walk is that the Vilta-Larsen treated patients start to separate or show an improvement relative to the external natural history comparator group as early as 13 weeks, and this was maintained for up to 25 weeks. Time to stand did not show a significant difference until week 25, and a similar result was seen for the 6-minute walk test, where a significant difference was observed at 25 weeks. This is the safety profile for Viltepso. As I mentioned earlier, upper respiratory tract infection, injection site reaction, cough, and pyrexia is a fancy word for fever, as well as some other adverse reactions that you can see here. Oops. Urticaria is also called hives. This is my last slide. So NS Pharma is committed to bringing forward treatments for Duchenne muscular dystrophy. I've spent most of my time talking about Viltepso, an exon 53 therapy. Our next therapy that we wish to initiate a clinical trial is for exon 44, and we're hoping that will begin this year. And then following on that will be exon 45, 50, exon 51, and 55. These are in an earlier stage as shown on this graph. And so the one that's ready first will be the one that we bring forward first. And with that, I thank you for your attention.
Bene, ringraziamo anche il dottor Crozier.
Thank you to Dr. Crozier. And as he said, all speakers will be more than happy to answer questions when the time will come at the end of all of the contributions and presentations. Let's get going. Third contribution. The presenter is Ash Dugar, Global Director of Dyne Therapeutics, and he'll talk about the program of development of their activity designed to study the efficiency of the experimental drug of exon skipping within the muscle cells. We see the initial trial of the skipping of exon 51, and we are very, very forward-looking to hearing what Dr. Dugar is going to be telling us.
Wonderful. Can you hear me okay? Can you hear me?
Yes, I think that everyone hears you.
Wonderful. Hello, I'm Ash Dugar, the Global Head of Medical Affairs at Dyne Therapeutics. First, thank you to the organizers of the Parent Project Italy meeting for a wonderful conference and for inviting me to present. It is a real privilege to speak with you today. I do wish we were seeing each other in person. Today, I'll be talking about Dyne's FORCE scientific platform, the newest data from the Duchenne program, and our clinical development plans.
Remember, please, to speak slowly. Thank you.
Of course. Yeah. These are our forward-looking statements for your reference. So at Dyne, it all starts with our mission. We are laser focused on delivering life-transforming therapies to patients with serious muscle diseases, with Duchenne being a priority. Our mission is core to who we are and what we do every day. So we are building Dyne as the leading muscle disease company to deliver for families living with Duchenne and other muscle diseases. Shown here are the 4 core strengths to help us deliver on that. First, we intentionally designed our FORCE platform to overcome the limitations of muscle tissue delivery with modern oligonucleotides. And I will talk more about the FORCE platform in a moment. Second, we've generated very exciting preclinical data that shows the power of our FORCE platform across different conditions and in Duchenne in particular. And I'll highlight some of this data in the presentation. Third, we will advance our programs as fast as we can to the clinic. We're driving 3 programs to the clinic with Duchenne and myotonic dystrophy type 1 as our co-lead programs. And finally, I would emphasize that we have a world-class scientific advisory board, which includes luminaries such as Dr. Francesco Muntoni and Dr. Lou Kunkel. This slide provides an overview of Duchenne, which you all know well. Our goal is to develop a best-in-class exon skipping treatment targeted to skeletal, respiratory, and cardiac muscle that greatly increases dystrophin expression and has much less frequent dosing than current agents. Now, our FORCE platform consists of a specific delivery mechanism called a Fab, or an antigen binding fragment, that we have engineered to bind to a receptor called TFR1, or transferrin receptor 1, that is found across the surface of muscle cells, including cardiac, skeletal, and smooth muscle. The Y-shaped structure on the left is what a full monoclonal antibody looks like. Our FORCE platform uses the top piece the Fab, which binds very tightly to the TFR1 receptor on muscle cell walls. Now, the Fab acts as a kind of key that unlocks the TFR1 receptor and allows our therapeutic antisense oligonucleotide, or ASO, to enter skeletal, cardiac, and smooth muscles to target the genetic cause of Duchenne at the level of the nucleus. We link our Fab to the potential therapy with a linker. The linker molecule connects the Fab to our ASO, a phosphorodiamidate morpholino oligomer, or a PMO, which gets in the nucleus. In the case of DMD, our current potential therapy is targeted for exon 51 skip amenable mutations. Now, historically, the challenge, as I stated earlier, has been the inability to get enough of the PMO into muscle cells. And our FORCE platform is designed to solve this delivery issue. Now, I have a short video showing the mechanism of action of the FORCE platform. I hope that it plays appropriately and that you can hear it. If not, please let me know.
Non so se la regia può intervenire per cercare di ripristinare l'audio del...
We have lost you,
You've
Dr.
lost the
Luger.
audio?
Yes, we lost the audio. We couldn't hear a word of what you said, unfortunately.
Okay.
We only saw
All right.
the video, which was
Okay.
progressing.
Yeah, so the video has a voiceover, and I was worried you wouldn't be able to hear it. So I'll continue on in the presentation, and this is also available on our website. So on this slide, we show our FORCE platform in the MDX model, a standard model in Duchenne. These MDX mice have a mutation in exon 23. In this study, we wanted to understand the magnitude and durability of exon skipping and dystrophin production in the quadriceps, diaphragm, and heart. Here you can see that the FORCE conjugate resulted in robust and durable exon skipping and dystrophin production across these key muscles with a single dose of 10 or 30 milligrams per kilogram. Now, the profound exon skipping reaches its peak at week 1, and you can see that on the top half of the slide. And you see the highest levels of dystrophin production on the bottom half at week 4 and extending out to 8 to 12 weeks, depending on the muscle. We were able to achieve very high levels of exon skipping in the quadriceps, diaphragm, and heart, where even at week 1, we see over 40% skipping in the quadriceps and heart, and over 30% in the diaphragm. And we saw resulting changes in dystrophin restoration, which you can see on the bottom half of the slide. At 30 milligrams of FORCE, you can see over 40% dystrophin restoration at 8 weeks in the quadriceps, and about 90% in the diaphragm and 80% in the heart, both at 4 weeks. We're extremely excited to see these levels of dystrophin restoration, especially in the diaphragm and heart, where current PMOs have had limitations. On this slide, on the top panel, we show dystrophin localization in the sarcolemma after a single dose of 30 milligrams per kilogram. This localization is important to see to provide confidence that there will be functional benefit. We see profound results, including over 80% dystrophin positive fibers in the quadriceps at 8 weeks, and about 80% in the diaphragm and heart at 4 weeks. Next, we evaluated DYNE-251, our clinical candidate, in non-human primates or NHPs. In this study, we looked at multiple dose regimens, as you can see here. And then we measured exon skipping in the quadriceps, heart, and diaphragm. Please note that in this model of NHPs, we cannot look at dystrophin restoration because these are healthy animals. And really the key message is that with our FORCE platform, time on therapy matters. The 2 and 4 doses of 30 milligrams at 4 weeks are comparable in exon skipping. And then when you look at 8 weeks, we observed much higher levels of exon 51 skipping across muscles. And again, I would point to the heart and diaphragm. And what you can see at 5 weekly doses out to 8 weeks, we saw about 50% exon skipping in the diaphragm, 40% in the heart, and 20% in the quadriceps. We also looked at the toxicology in the NHPs, and we saw that DYNE-251 was safe and well tolerated in this model. Now, as we prepare to launch our DYNE-251 clinical development program, we have gained a lot of expert feedback. KOLs, both in the US and in Europe, have provided advice on our overall clinical program, including the trial design, patient population, biomarker and functional endpoints, and key safety considerations. It's also clear that these thought leaders believe dystrophin continues to be a key endpoint for the disease. We've also received advice directly from patients and caregivers, as well as advocacy leaders such as those from Parent Project Italy. And this input has been critical in ensuring a patient-centric design that has included key considerations for choosing a trial, feedback on biopsies and functional outcomes, and how to ensure patients and families are supported throughout the process. So based on this feedback, I'll go into some of the key elements of our trial. Our clinical trial will be a global multiple ascending dose, or MAD, placebo-controlled study with a long-term extension. We plan to enroll patients with Duchenne who have mutations amenable to exon 51 skipping therapy. Our goal is to enroll about 30 to 40 male participants aged 4 to 16 years old who are either ambulant or non-ambulant. And we will look at safety, tolerability, and dystrophin by Western blot, as well as measures of function in both ambulatory and non-ambulatory participants. Please note that we submitted our IND to the US Food and Drug Administration, or FDA, in December of 2021. As many of you may have seen, we communicated to the community that the FDA placed us on clinical hold. We also sent a letter to the community about this event. We understand that the term clinical hold can be very concerning to the Duchenne community, given the history of clinical holds for other therapies in development for Duchenne. It is important to note that DYNE-251 is not yet in the clinic. So this clinical hold is not related to an incident in the clinic or in a Duchenne patient. The clinical hold asks for additional information about our program. We will respond to the FDA's request with data from existing and ongoing studies in the second quarter of 2022. And if satisfactory to the FDA, we will begin dosing patients by mid-2022 as we've stated previously. And more details about our study will be available closer to when we begin dosing patients. While our initial focus is on our exon 51 program, our goal is to be able to build a franchise to address the 80% of patients with Duchenne amenable to exon skipping. This slide importantly recognizes just a few of the very many voices and comments that we hear. We're committed to understanding the community of people living with muscle diseases and Duchenne in particular, and ensuring your perspectives and experiences are included in our drug development programs. And finally, on this slide, you can see Ravi, Beth, and Diana and their families, who are all part of the Dyne family. At Dyne, we make decisions with patients and families in mind, and this is absolutely what drives us each day. Thank you.
Siamo noi che ringraziamo lei, dottor Ducar. Ci scusiamo per il momentaneo.
Thank you, doctor, and we apologize for the trouble that did not enable us to listen to the video, but never mind, because we completely understood the work that you do for us.
Thank you.
And now I would like to give the floor to someone from Avidity Biosciences. They have developed a new generation platform that can increase efficiency of treatment. The first molecule is designed for the skipping of exon 44. And to speak about this in a pre-recorded video is Dr. Mark Stahl from Avidity Biosciences. Grazie alla Parent Project Italia di avermi invitato.
Avidity Biosciences. I'm excited to share information about us, our science, and our work with the Duchenne community with you today. These are our forward-looking statements. Our mission at Avidity is to improve the lives of families impacted by rare diseases, including Duchenne muscular dystrophy, through the development of new drugs. We are a biotechnology company based in La Jolla, California. We are grateful and honored to serve the Duchenne community and have the opportunity through events like this to hear the perspective of people with Duchenne and their families and caregivers. We consider patients to be at the heart of everything that we do. Our commitment to rigorous and innovative science is matched only by our passion to see improvements in the lives of the people we serve. We are also very grateful to patient advocacy groups like Parent Project Italy that help connect us together. Today, I'd like to talk about the drugs we make at Avidity, how they work, and how we plan to use them in treating Duchenne. Our drug technology is called the AOC, the Antibody Oligonucleotide Conjugate. AOCs provide a new way to deliver drugs directly to affected cells, like muscle and heart cells. The AOC platform combines proven technology of existing drug types that are well understood for each of their important properties in drug development. The first part is the antibody. An antibody is a naturally occurring protein made by your body to help fight infections. Antibodies are commonly used in drug development because they can be made to target almost any protein, including those that are different between one cell type and another. Antibodies are well characterized for their safety and are the foundation of over 100 approved drugs, many of which are used in chronic conditions. At Avidity, we use the antibody as a vehicle to deliver our drugs to muscle cells. The second part of our AOC platform is an oligo, or oligonucleotide. An oligo is a short strand of DNA or RNA. Oligos can be powerful drugs because they can change gene expression, or how the body makes a protein by targeting RNA. There are currently multiple approved oligo-based drugs, many of which are used in disease-modifying treatments. At Avidity, we use oligos in our AOCs that are created specifically to target the genetic cause of disease. For muscle diseases, the antibody component of the AOC enables targeted delivery to muscle and heart cells, and in turn, improves the power of oligos. The antibody has a unique ability to recognize and stick to a specific protein on the surface of these cells that delivers more oligos that change the gene expression. Specifically, the antibody binds to a transporter protein called the transferrin receptor 1 on the muscle cell. It is then carried inside the cell where the oligo is released. You can think of our antibody as a bus that's taking its passengers to a very specific bus stop and then letting them off to go to work. In our case, that bus stop is a muscle or a heart cell, and the passenger's job is to help make dystrophin. The combination of antibodies and oligonucleotides that make these drugs, called AOCs, result in the ability to target specific cells in the body, the heart cells and the muscle cells, and modify their gene expression, as we are working on with dystrophin. This is allowing us to develop new treatments for diseases where current therapies are limited, all in the service of improving the lives of people affected by these conditions. Currently, Avidity is developing 3 different drugs that work via the exon skipping technique that has been discussed earlier in the meeting, and I will explain a bit later. These are drugs designed to treat the root cause of DMD in individuals who are amenable to skipping of exons 44, 45, or 51. Our first program is called AOC 1044, and it is designed to treat individuals whose gene mutation is amenable to exon 44 skipping treatments. We plan to apply learnings from the research and development of AOC 1044 to our other programs in Duchenne. Taken together, we aim to be able to treat about 30% of the total Duchenne population with exon skipping technologies. Here, I will talk a little bit about how our drugs work in more detail. As I mentioned, our oligos work via something called exon skipping. Skipping an exon ultimately results in the production of a slightly shorter but still functional version of that dystrophin protein. Here's how it works. Many mutations that cause Duchenne result in the gene sequence becoming what's called out of frame. This means that when the genetic code is read by the cell, a stop signal is encountered, resulting in the production of little or no dystrophin protein. Exon skipping causes the cell's genetic material to skip that stop sign, restoring the reading frame. This results in the production of dystrophin where before there had been none. Currently, there are 4 approved exon skipping treatments for subsets of the DMD community. Each is designed to skip a specific exon. Particular mutations are amenable to skipping of only a specific exon, if any, so it is important to know which mutation an individual carries. However, there have been some limitations to the currently available therapies. The current treatments are based on the use of unconjugated or naked oligos. They are not attached to any antibody or other delivery vehicle. Without targeted delivery the antibody provides, oligos have inefficient uptake by muscle and heart cells and require frequent dosing. Our AOCs combine antibodies that target muscle and heart cells with exon skipping oligos. In this diagram, you can see the AOC is on the left. The antibody part of the AOC has a unique ability to find a specific protein, the transferrin receptor, on those muscle and heart cells and deliver that oligo into those specific cells. Once delivered, the oligo enters the cell to modify the gene expression by targeting RNA. By combining the oligo and the antibody, we are able to more efficiently deliver the oligo directly to muscle and heart cells. More oligo is therefore able to enter those cells and increase exon skipping, which in turn can lead to increased production of the dystrophin gene product. Here, I will show just a little bit of the data our scientists have been generating with our technology. In this experiment, we used muscle cells from boys with DMD, amenable to exon 44 skipping, and we tested our oligo. We achieved substantial exon skipping, up to 60% of the RNA produced. In lab studies, AOC 1044 was seen to be very specific for exon 44 with no off-target effects. AOC 1044 also showed a long duration of action, meaning it could stay active in the body long enough to allow for monthly dosing. In this experiment, we used a mouse model in which we could compare the exon skipping ability of unconjugated or naked oligo directly to one which is part of an AOC. This helps us understand the effect of linking the antibody to the oligo on the effectiveness of the drug. You can see that treatment with the AOC led to a greater than 50-fold increase in the degree of exon skipping compared to an unconjugated oligo in a mouse model of DMD. At Avidity, we are committed to partnering with the DMD community to bring forth meaningful treatment options as we strive to continue to partner with the DMD community and incorporate the patient voice into everything we do. We are continuously working with and supporting advocacy groups to ensure that we are continually seeking input from the community throughout the drug development process. By collaborating with key groups like this one and community leaders, it will ensure that we are addressing any gaps in support services and resources. Here are some key takeaways from my talk today. We are very excited by the potential of Avidity's AOCs to treat the root cause of Duchenne. Preclinical and animal studies are ongoing. And in preclinical studies, we have seen increased exon skipping that allows for the production of dystrophin protein with our AOC treatment as compared to naked oligonucleotide treatment. Our AOCs are expected to be administered with infrequent IV dosing, and we are planning to initiate our first clinical trial with AOC 1044, currently in development for the treatment of boys who are amenable to exon 44 skipping by the end of this year. Finally, one of my favorite slides. These are some of the Avidity team members who are the faces of the company and are working hard every day to address the unmet needs of patients and the DMD community. We are an extremely passionate group and love the work that we do. It's our privilege to serve this amazing patient, caregiver, and advocate community. We are always hoping to listen, learn, and connect with the community. So please feel free to reach out to us. You can connect with us on the bottom, at the address at the bottom of your screen, patients@aviditybio.com. Again, thank you for your attention.
Allora, anche se questo era un messaggio preregistrato,
Now, this was a pre-recorded message, but Dr. Mark Stahl is logged in and he will be more than happy to respond to the questions. And now the next contribution. This is a new company that we've come into contact with in the last year, known as PepGen, that is leading forward a program of development of exon skipping with the Duchenne, and they will be talking about the innovative approach that was fine-tuned to allow for the delivery of the experimental molecule to the target muscle cells. And we shall now hear from James MacArthur. Please do take the floor.
Thank you very much for the invitation to go and speak to you about our work. I'm really excited for PepGen presenting what we've been doing and where we're going with new innovative therapies for neuromuscular diseases. First, my disclaimer slide. Now, the approach that we're taking at PepGen is based on over a decade of academic research and research at the company to go and develop the next generation of enhanced delivery oligonucleotides. And this is based on what you see on the left-hand side, a peptide-based approach that encompasses both positively charged sequences as well as hydrophobic sequences, which then get conjugated to the therapeutic oligonucleotide to create an oligonucleotide that can now very, very efficiently get into the cells that really matter for patients living with Duchenne muscular dystrophy. We represent the next generation, we believe, in the work that many people have done, and we are building upon all of that knowledge and benefiting from that, both work by other companies, academics, as well as patients, to go and derive next generation therapies that uses an exon skipping approach as been described previously, to go and create a slightly shorter but functional dystrophin protein that will benefit patients and hopefully allow the arrest of disease progression. Now, our particular step change involves not only enhanced delivery to not just skeletal muscles, but diaphragm, cardiac, as well as to the CNS, which could benefit certain neuromuscular diseases. And we can, with this, go and achieve the highest level of exon skipping potency at tolerable target doses of any exon 51 developed therapy currently in development, we believe. Further, this, we believe, will turn into our ability to produce greater amounts of dystrophin protein in patients, which should have a greater impact on the disease. And we've spent a tremendous amount of time through this work really trying to balance this tremendous activity of delivering therapeutic oligonucleotides into the cells that matter with tolerability so that we can dose patients long-term and have a true meaningful impact on patients. We've also spent a tremendous amount of time on developing a robust, scalable, and cost-effective manufacturing process so that we can rapidly translate not just our first program in neuromuscular diseases, but our second and third and fourth programs, and rapidly move them into clinical studies to see if we can benefit patients. The approach we're using, which has been previously described, is to go and take established technology, exon skipping oligonucleotides, that, as I'd mentioned, allow one to go and create a slightly shorter dystrophin protein that is now functional in patients, Each of these is tailored to specific patients who are amenable to different exon skipping approaches. And our first approach will be an exon 51 skipping approach. As I'd mentioned, this work is based on a tremendous amount of research and preclinical work. We, for instance, have been able to demonstrate that these enhanced delivery oligonucleotides are able to produce really dramatic levels of dystrophin expression, even at rather limiting doses in most models of muscular dystrophy, not only in skeletal muscle, but also in the diaphragm and other tissues. Now, we've spent a tremendous amount of time developing this work in non-human primates. And the reason for this is we really believe this is an excellent model for translating the potential potency of these molecules, as well as understanding the safety of these molecules. In the study I'm showing you here, following a single dose, we can go and show that we produce exon 51 skipping levels in skeletal muscle of 60%, diaphragm 70%, and in the heart almost 20% at a rather low dose of 20 milligrams per kilogram. As we increase the concentration of the drug that we administer, we can go and see higher and higher levels of exon 51 skipping. Now, with more exon 51 skip transcript, we anticipate seeing more dystrophin production in patients. It was really critical to understand how does this technology compare to what is the most clinically advanced program today. This is a program that involves something called R6-gly, or 6 arginines connected through glycine to the exon skipping oligonucleotide. And this is shown to have a dramatic impact on increasing the delivery of therapeutic oligonucleotides into cells and produce higher levels of exon 51 skipping and higher levels of dystrophin production. So we ran a study against an identical like molecule against our clinical candidate, which we call EDO51. We looked at 3 different doses in non-human primates and a wide different range of dose levels. When we go and look across skeletal muscles, whether it be bicep, quadricep, or the lats, we can go and see that at our top end of the dose range of 30 mg per kg, that we are producing 80%, 75%, 65% in the bicep, quad, and lat, significantly more than what's seen with the other approach. And this suggests that we may be able to produce more exon skip transcript and potentially benefit the patients better. If we go and look at the heart or the diaphragm of these same monkeys, we can go and see at 30 mg per kg, we're producing 25% exon 51 skipping levels, compared to rather low levels with the more advanced molecule, comparing the teal to the purple. In the diaphragm, even at doses of 10 mg per kg, we see really dramatic levels of exon 51 skipping, and these only increase as we go to 30 mg per kg. These data have given us great hope that indeed, as we move this program forward clinically, we may be able to produce a real step change in terms of not just exon 51 skipping in patients amenable to this approach, but also produce higher levels of dystrophin protein. Now, as I'd mentioned, it's really critically important that we not only see excellent delivery and exon 51 skipping, but that we also see really good tolerability. And indeed, when we go and look at the CTA enabling studies, the studies necessary to move forward with human clinical studies, we can go and see that the drug was very safe and well tolerated in both rodent as well as non-human primate models. And indeed, as we look at multi-dose studies, and these were non-GLP studies in non-human primates, again, the drug was very safe and well tolerated. But the one thing we did see is hypomagnesemia, which was referenced earlier, which we believe ultimately clinically will be manageable. So where are we today? We've now completed not only our non-human primate repeat dose studies, but also all of the studies necessary to move forward with filing a CTA, a clinical trial application. This is the first step in moving a drug into human clinical studies. We've now submitted that CTA and are awaiting feedback from the regulatory authorities. We anticipate having from this study, which will be conducted in volunteers who do not have the disease, not only safety data, but we also anticipate getting some exon skipping data. Although we do anticipate these levels to be rather low based on what others have seen previously. But we anticipate having this data that will allow us to move into patient studies in individuals amenable to an exon 51 skipping oligonucleotide approach in early 2023. And we look forward to sharing more information as we do so. As I'd mentioned, this EDO technology allows us to access many tissues that are important: the brain, the heart, the diaphragm, smooth muscle, and skeletal muscle. All of these are targets not only for Duchenne muscular dystrophy, but other neuromuscular diseases. And so we really think this ability to target all of these tissues and be able to see increased levels of delivery of therapeutic oligonucleotide and potentially higher levels of exon skipping with that will benefit patients long-term. PepGen is a company created to truly develop transformative therapies for neuromuscular diseases. And what I'm showing you on this slide is the programs we currently have underway and where they are in terms of that program. So as I'd mentioned, our EDO51 for individuals amenable to an exon 51 skipping approach, that we're moving into phase 1 clinical studies this year. Our second program focused on myotonic dystrophy. That will be completing preclinical studies to enable moving into human clinical studies for next year. Our third exon skipping approach is an exon 53 skipping oligonucleotide, of which we are developing the non-human primate data, similar to what I showed you for our exon 51 skipping approach this year. And on the basis of that, we'll move forward with the studies necessary to move into patient studies. And lastly, we are also interested in looking and applying this technology to other exon skipping approaches: exon 45 amenable individuals, exon 44 amenable individuals, and going beyond that, with our hope that we can deliver really transformative therapies for patients who would benefit from exon skipping approaches. And this could be as many as 60, 65% of the DMD patient community. And with that, I would conclude, and thank you very much for listening.
Grazie, grazie dottor MacArthur. Passiamo all'ultimo intervento che...
Thank you very much, Dr. MacArthur. Moving on to the last presentation. The last speaker needs no introduction. Professor Eugenio Mercury from the Gemelli Hospital in Rome, greatest expert in this pathology, who in addition to doing a lot of exon skipping trials, follows a lot of patients under treatment. So he will speak to us about nonsense mutations. Professor, you have the floor. Thank you. I'd like to share my screen, please. To finish our day, we're going to talk about nonsense mutations. Treatment we have available in Italy and in many parts of Europe. Translarna. Translarna, we know, has been available for many years, and we know that it is indicated for the treatment of nonsense mutations in DMD. It facilitates the translation of some nonsense mutations, and therefore it facilitates the production of a functional protein. We're very familiar with the drug because several trials were conducted. This is a table for phase 2b and phase 3 trials that were carried out and completed, which led to the approval of the drug. I wanted to briefly show, by way of summary, because these were completed quite a few years ago. This year, a meta-analysis trial was carried out. It looked at what happens in the different trials and if what we observed in one trial is then observed in others. This outline shows that wherever there were trials with a placebo group, in all studies there were always results that were in favor of Translarna vis-a-vis the placebo, meaning that children treated with Translarna always did better than the placebo group. Even where there was a little bit of a prediction of the disease was slower in progression than it was in placebo patients. These trials, as we know, are always performed in selected populations to approve the concept. And when the drug was accepted, it was very evident that there was an underpopulation of children and adolescents with DMD that seemed to benefit more than the others. So the proof of the pudding was to find out what would have happened once the drug would have become commercially available to all, well, to the whole DMD community that could walk, and what happened when the inclusion criteria were not there. Now, the results refer to Translarna, but we're interested in demonstrating the value of this drug in the real world. A registry was used called STRIDE, and many countries adhere to it. So clinicians of many European countries enter data in this registry whenever we see patients who are treated with Translarna. You see, this is a very long trial, and for 5 years, we have the obligation to report in the registry the assessment of our patients treated with Translarna. This is a map of the countries that have adhered to it. We and the UK are very enthusiastic about entering the data in these registries. We understand their importance, and we really understand the importance of having these data because we need to better understand the efficacy of the drug since it's a long-term drug. Now, how were patients assessed? Well, analyses were carried starting with a population of 269 treated patients who had been diagnosed before 5 years of age on average. This is not surprising because we know that nonsense mutations are not identified immediately with routine tests that we're used to performing when there is a suspected DMD. So sometimes this delays a diagnosis compared to diagnosis usually done in other patients suffering from the same disease. The mean age at which treatment was initiated was 9.2 years. This is a distribution of the patients. It shows you the age at which they began treatment. The duration of treatment was about 3 years. It's interesting to see that 86% of patients, so a large majority, had at least a 2-year follow-up. So the data I'll be showing you now are ones that can be obtained not just in the short term, but even in a longer term, longer than what we had seen in clinical trials. The safety profile of Translarna is very good. Even in the real world, we were able to confirm this. The safety profile is really very good. Only a very small number of patients suffered from side effects, and none of them were life-threatening. In order to evaluate these data, because in real life we don't have a placebo, we can only use controls, and the control that we used were data coming from the Synergy group. This was the first network. It's in the US that started to collect natural history data sequentially and reliably together with this database, which makes it possible to recognize subgroups that are a good benchmark for the registry. The method that was used, and if any of you might be interested, I can go into this later, is the propensity score matching. So patients who had the same characteristics as patients who were treated. In orange, you have when they started steroids, duration of treatment with steroids, and age at which therapy treated was commenced. In Synergy, we found patients with the same characteristics and created a control group that was very similar to the treated group. When we correlate what happens in the natural history patients who were treated only with cortisone compared with those patients that were treated with cortisone plus Translarna, we see that the possibility of losing ambulation varied greatly between the two populations. In red, you have the patients in the registry, i.e. patients receiving Translarna, and loss of ambulation happened later on. 5 years. It took them more than 5 years to lose deambulation compared to the other patients. If we look at the other aspects, for example, respiratory capacity, and when it goes below 60% FVC, you see that the red line is shifted relative to the blue, and that indicates that the time at which the patients go beyond 60%, which is sort of an alarm bell. Well, this value was reached in treated subject a year and a half later than it was in untreated patients. And the same goes for an even more restricted value, i.e. FVC under 30%. You see that the trend goes in the very same direction. So these data basically show that with a longer follow-up and with a population that is less selective than that, or selected than that in clinical trials, that may have therefore potentially shown less than brilliant results. In spite of this, we believe that Translarna makes a difference. Of course, in the subpopulations in which Translarna is suitable, I didn't say this at the very beginning, but we know that Translarna is specific and works only in patients who have a small group of nonsense mutations. The registry is working very well. It's enlisted many patients, and it's nice to see that these registries, which are totally functional, are growing in number. This was the first registry that we used among those that we use for trials. It was used at a pan-European level, and the findings are very interesting. So the take-home message is that long-term treatment with Translarna seems to work, and these results seem to be even better, maybe, than those in clinical trials. And this, on average, would mean a delay in age, a loss of ambulation, and decline in loss of motor function and respiratory function. So far, the data obtained seem to suggest that it's a good idea to continue administering Translarna, but this is an opportunity to also thank all the families that always contribute their input and make it possible for us to have these registries, so that once drugs are approved, these are the only means that we have to ensure that the drugs are safe and efficacious, even in large populations. Thank you. Thank you very much. We all thank you, Professor Mercury, for your presentation. And before we open the floor for questions, I'd like to thank all the speakers, all presenters, for being willing to be part of our conference. The families are very keen to join us year after year. And then we'd like to thank you for your daily commitment to fight against DMD and BMD. We confide in positive outcomes, and we also hope to see each other in person as soon as possible. This being said, I now would like to give the floor to Ilaria for the Q&A session.
I join in the thanks extended to all of the speakers. All of their contributions were highly interesting. And today I have Fernanda here with me. She has joined in for the Q&A session, and she has the floor for the first question. Good evening, everyone. I'm once again here in this incredible spaceship. And the first question is for everybody. Whomever feels like answering may be free to do so. What is the percentage of dystrophin that you'd like to have in order to say that the treatment was effective? And on top of that, how can you explain that two boys, same age, developing same percentage of dystrophin may then develop a different muscular force, a different muscular force? I think that this is what she said. There are some sound problems, unfortunately. Anyone volunteers to answer this question? I will start saying something. Okay, thanks. Well, let's say that the idea is that the more dystrophin we can produce and the happier we would be. But we already know, out of what happens in nature and in the real life, that the patient skipping exon 44 physiologically show some and display some dystrophin traces, which make it possible for these boys to do more things and fare a little better as opposed to those who do not produce the protein at all, because we know that even tiny percentages make a difference in the evolution of the disease. And if we produce more, we have more possibilities in trying to allow for the decline of the disease and in order to be more stable, if not seeing some forthright progression or improvement. And the commitment towards the new method that we're presented today seem to be allowing us to think that there is more production of the protein. And this is seen with great interest. As a clinician who has been involved in this for so many years, I must say that I've seen changes in natural history. And it's important to say that tiny increases in the protein production can make a big difference. They are already doing that. We are never happy. And we are very much happy to see that there are new treatments, new therapies coming in, having a great potential. And I think that however small the increase, it is already a great result. And the more we have, the better. Thank you. Thank you. Thank you. One more question coming from Costantino. Hi, Costantino. He's always very much present and he's very much active as well. The question is for Saretta. So John and Lorna, if you wish, you may then answer. Out of the very latest news, it seems that you are starting a TPMO trial of the exon 51 skipping in Spain and in Belgium. Italy, once again, is not included in the 51 exon skipping. Now, I am a father, and I've been trying to obtain, unsuccessfully, I must say, obtaining access to exon skipping 51. I was really hoping to have a possibility, thanks to the TPMO trial, which unfortunately is not coming in the short term in Italy. So once again, I would like to try and consider Italy as a site to try this trial, since just like in the rest of Europe, very few boys have had access to the trials of skipping of exon 51. Costantino, those are fake news. No. We will be participating. Who said that? Well, this is excellent news then. I don't know whether Lorna and John would like to add anything to this. PPMO, maybe John would like to say something about that.
Yeah, I think what we can say is that we're trying to reopen the sites which were already identified, in the study. And Italy was one of them. It's just a question of going through the appropriate processes to do so. But to be able to give a date of when that is difficult, because some of it's out of Sarepta's control. It's more around, you know, the authorities, the ethical review bodies, and access, you know, into the site. So Italy is certainly, you know, one of the countries we want to get into. It's all around when we can do so and how many patients we still need to recruit into the study.
Thank you. And if I may add, from the PMO programme, we are also planning to come to Italy with the mission study as well, the high-dose eteplirsen study of eteplirsen for exon 51 skip amenable patients. We do have sites in Italy for our Essence clinical study, which is targeting exons 45 and 53, and that's open and active in Italy currently.
Grazie, sì, abbiamo sentito infatti del mission.
Yeah, we've heard the mission, which is soon to be launched in Italy. But let me just seize this opportunity to say that in the course of this year, in Italy, we've been contacted together with other Italian centers involved in skipping of exon 51, but also of 53, 55, and 44. And once again, let me say that we should go on checking whatever evolution may occur within parent project news. In Italy, we may enroll so many boys, and we would still like to go on towards that direction. We have to be very careful with parent project. Whenever the studies are launched, we hold webinars. So please be alert and check PP, because we will not probably need to form a register to inform the families. Now here, an anonymous participant asks about intron mutations. Can you tell us something? The question is, can we apply the exon skipping wherever there is an intron mutation? Any one of you can answer. I mean, you are the experts here. I don't know if you've taken the floor, but we can't hear. Maybe Ash, you would like to answer?
It looks like school. It's better than someone volunteer.
Esatto.
Sorry, I'm happy to take it, but Eugenio, did you wanna take this one? It says
go on, Ash, go on.
Yeah. So for our technology, as you've heard, we are actually going to be looking at exon skipping. We're going to be focused on deletions of exons to apply the exon skipping PMO technology for the DYNE program.
Ok, grazie mille. Magari possiamo aggiungere che...
Many thanks. And we may probably add that the exon skipping technology can be hardly applied to the intron mutations. And we should even try to understand the context of the intron mutation and what may be the effect from the biological viewpoint, so as to reason a little bit as to the potential implementable strategies. That is not the ones that require a given type of mutation in general, and more in specific terms. We should also understand what kind of mutation that is, where it takes place, and what are the effects generated. So obviously, this is a question that entails a highly complex answer, but please do contact us. Keep in touch. Another question coming from Costantino, and this is for Ash. It is interesting to see the exon skipping approach through the antibody. Did you ever see any side effects in the primates? And how is the administration done, or the delivery? Do you think you will hit Italy or Europe with your own experimentation and trials?
That's great. Yeah. So let me try and take some of those in pieces. So as I did mention in the presentation, we've done toxicology work in non-human primates, which is an important step prior to going into the clinic. We have disclosed those results publicly from that weekly toxicology study that we did, and we saw no adverse findings. We saw no issues with liver, kidney, weight. No issues with kidney, liver function, weight changes, coagulation, and in that study, we actually dosed at doses much higher than the 30 milligrams that I showed in the slides. In fact, we dosed at what we called a maximally feasible dose, which means it was the highest dose that we could actually formulate into, to be able to give to the NHPs. And we saw that the drug was safe and well tolerated at this weekly dosing interval in the tox. And then to your very good question, what are we planning to do in the clinic? Now, we have not disclosed, right now we're still working the full study plans out. We haven't disclosed what the dose regimen will be in the clinic. However, it is highly unlikely that it will be weekly dosing. We feel that we can actually dose relatively infrequently, perhaps monthly, or even less frequently. So we have a great deal of data that we've been looking at that gives us confidence that we can move into the clinic safely and that we should be able to dose relatively infrequently. Again, hopefully no more frequently than monthly dosing, and it will be given intravenously. And then I think your last question was about coming to Italy. So right now, as I said, we're planning for a global program. And so we are evaluating sites all over the world, as well as Italy. So as we have more information on where our sites are going to be in the coming months, I'll be happy to come back, do a webinar, and provide more information. But we are looking at sites globally, including Italy.
Grazie Ash, ma noi siamo in contatto stretto.
Thanks, Ash. We keep in touch with you all.
Always.
And you are the very ones who are constantly asked the same question. If you answer back, we will communicate the results or the response to the families so as to allow for a trial in Italy, hopefully. Costantino again, that is for PepGen. The question is, would you say that the trial phase 1 will be launched in Italy and in Europe? As you can see, the Italian community is very much interested in the studies. There is full availability and willingness to do whatever we can so as to allow the studies to land in Italy in our own clinical centers.
Thank you. No, I really appreciate that. And getting input from the patients and the patient community is absolutely critical in terms of our success and everyone's success. The initial study that we'll be conducting will be conducted in volunteers. And the strategy behind that is to allow us to very rapidly get safety data in humans. And that allows us, hopefully, to move forward with higher doses when we begin patient studies, the multiple ascending dose study, which we'll initiate in the first half of next year. And so that's the rationale for doing this study. So it would not impact patients, this first phase 1 study, because we won't be in patients, but we look forward to using what we learned from the study to rapidly advance it forward, both in the United States and in multiple European countries, of which Italy is high on consideration as a site, given the tremendous network and patient organizations there.
Ok, grazie mille. A questo punto aggiungiamo la domanda anche per Mark Stahl di Efficacy Bioscience, se anche loro stanno pensando a dove svolgere il loro studio.
I'm sorry, Mark, that was for you. Do you consider Italy for your next studies as a possible site?
Yes, thank you. That's a great question, and I'm happy to join the group of folks who have been asked that. we of course are looking globally as well. At this point in our development, we have not made a decision on all of the sites that we'll be working with our trials. But of course, as other respondents on the panel have discussed, Italy is has a large number of positive attributes that would make it a great site, including the enthusiastic participation of groups like this, and the infrastructure that comes with leading like Eugenio's and here. And so we are very much considering Italy as a site that we will be working with in our trial design. Thank you.
Thank you. This is another question for Saretta. We know that there are high-dose studies with eteplirsen. What are the differences existing with the high-dose eteplirsen and high-dose studies? Which ones are the ones delivering more effective results? Is it for to approval in the UK and in Europe in the near future? Possible.
So I can say that essentially we're looking at two different technologies and really not suggesting that one is better than the other. We want to prove there's advantages over one versus the other. You know, and both studies are running. Both are or will end up with trials which are appropriate for approvals outside of the US in our planning process. So I think it's, you know, there are different attributes of both the PMOs and the PPMOs, and I think it's really to demonstrate which has the greater potential to be a, you know, a drug that's going to give more benefit than is currently being seen.
Thank you, and thank you for the question. And if I may add regarding the registration outside of the US, so we really are very committed to advance our registration trials, so for Essence and Mission as quickly as possible, and work with the regulatory authorities to serve patients with Duchenne and ensure that we have equity of access for all patients. So this is something we take very seriously and continue to work with the agencies.
Well, we shall follow all of the updates. Fernanda, this is a question for Professor Mercury. The propensity score match was also taking into account the nonsense mutation in the synergy group? No, only in part, because we didn't have sufficient numbers. And another thing that I would like to say, because this is something we are currently trying to do, we are trying to understand, thanks to the collaboration with Professor Perlini, a different way to look at the mutations to try and understand whether we can identify on the basis of the type of mutation and within the mutation there are nonsense mutations, whether there are deletions that seem to have a clinical course, also as a consequence of the treatment, in response to the treatment. So we are digging deep to try and understand what is the variability in terms of natural history, but also in other terms. Many thanks. That's very interesting indeed. Ilaria. This is not a question, but it is rather a message. And I would like to read this the way we got it. It came in English, and it says,
but more is better. And greeting to all the speakers from Anemiche, which you all know, I'm sure.
E che noi anche salutiamo tantissimo.
And we also would like to meet you as soon as possible. This is a question for everybody and open to everybody. Are there any planned clinical studies for the skipping that are amenable for the out-of-frame deletions from 3 to 7? Skipping for patients having a skipping for the deletion from 3 to 7. We didn't hear that in your own updates. We haven't heard about your plans, but maybe you're already having laboratory studies and you may want to share with us it's something that is missing so far.
Non mi sembra. Possiamo concludere di no?
Not. I guess we can say no. There are no updates. Are there? No?
Okay.
Well,
no.
Okay. Let's take it for a no. Ilaria, one very similar question. Are we expecting an exon skipping possible even in the absence of exons 53 and 54?
Well, maybe I can jump in. This is Robert. Yes, we are anticipating studies in exons 50 and 55. So patients who have mutations that are amenable to exon skipping for 50 and 55, as well as 51.
Ok, grazie.
Thank you.
Ci dicono dalla regia che sono le domande.
And we have no more questions. So let's conclude this very long day. Many thanks to all of you, the participants, the speakers, and all of those who stayed with us for the entire day and for all that were logging in from home. Tomorrow's we will meet again or log in again at 10:30 with a round table having to do with the COVID impact in everyday life. In the afternoon, there are going to be more scientific sessions. First intervention will be by Professor Racca, talking about the PJ Nikolov protocol and the emergency card. Then we have other contributions having to do with the Becker dystrophy and other clinical trial, which are not aiming at restoring the dystrophin, but rather aiming at looking at what happens to cells. Thank you, Fernanda, for being here. Thank you, Ezio, for his co-moderation. Then Gloria in the backstage, thank you. And again, have a nice evening and let's meet again tomorrow. And thank you. Many thanks to all of you. And we all wish you a pleasant evening.
Thank you.
Thank you very much.
Thanks all.
Thank you. Good evening.
Thank you all.